Hello friends, welcome to Tneb Teach Education. So உங்க preparation எல்லாம் போயிட்டே இருக்குன்னு நினைக்கிறேன். So let's start the session. 2 lamps each of 230 volts and 60 watt rating are connected in series across a single phase 230 volt supply. The total power consumed by the 2 lamps. அவ என்ன சொல்லிருக்காங்க क्वेश्चनல நீங்க பாத்தீங்கன்னா 2 lamps கொடுத்திருக்காங்க. அந்த 2 lamps ஓட ரேட்டிங் வந்து 230 வோல்ட் 60 வாட் ரேட்டிங் கொடுத்திருக்காங்க. சோ ரெண்டு வந்து சேம் ரேட்டிங் தான். ஓகேவா, ரெண்டு வந்து சேம் ரேட்டிங் தான். இது வந்து 230 வோல்ட்க்கு கனெக்ட் ஆயிருக்கு. 230 வோல்ட் கனெக்ட் ஆயிருக்கு. ரைட். சோ இந்த 230 வோல்ட் கனெக்ட் ஆயிருக்க டோட்டல் பவர் கன்சியூம் பை 2 lamps எவ்வளவுன்னு கேட்டிருப்பாங்க. நம்ம என்ன பண்ணுவோம், எக்ஸாம் ஹாலுக்கு போன உடனே ரொம்ப ஈஸியா இருக்கு. 1 மார்க் क्वेश्चन பவர் ஈக்குவல் டு P1 P2 60 plus 60 120 watts high page. So இதெல்லாம் ஒரு क्वेश्चन இவன் கொடுத்திருக்கான் 1 மார்க். ஆக்சுவலி போவோம் வெளியே பார்ப்போம். 121 மார்க். அதுக்கப்புறம் நாங்கள் கீ வரும் அப்சல்யூட்லி ராங் ஆயிருக்கு. நாங்கள் கீ வந்ததுக்கு அப்புறம் 120 watts அப்சல்யூட்லி ராங். நம்ம என்ன பண்ணுவோம், அதுக்கப்புறம் கீக்கு சேலஞ்ச் பண்ணுவோம். ஓகேவா, ஒண்ணுமே வராது, காசு வேஸ்ட் தவிர. சோ நீங்க பாத்தீங்கன்னா பவர் இன் சர்க்யூட் தியரியில P average equal to power consumed equal to or power consumed வந்து P average தான். instantaneous power அவன் கேட்டாதான் क्वेश्चनல average power equal to VRMS square by R or IRMS square into R or VRMS square into G or IRMS square by G. So இது நமக்கு தெரிஞ்ச formulas in network theory. So இந்த supply voltage என்ன, அவன் டைரக்டா supply voltage கொடுத்துட்டான்னா இது RMS voltage. இது வந்து RMS voltage தான். ஓகேவா, சப்போஸ் அவன் 238 கொடுத்தா இது வந்து RMS voltage தான். 238 30 degrees கொடுத்தாலும் இது RMS voltage தான். So டைரக்டா in phasor கொடுத்துட்டாலும் டைரக்டா வந்து 230 volts or 110 volts சப்ளை கொடுத்துட்டாங்கன்னா அது வந்து RMS வோல்டேஜ் தான். ஸ்பெஷலா அவன் வந்து மேக்ஸிமம் வோல்டேஜ் ஸ்பெசிஃபை பண்ணாதான் நம்ம வந்து அதை கன்சிடர் பண்ணோம். ஓகேவா, சோ இந்த லாஜிக் வந்து நல்லா ஞாபகம் வச்சுக்கோங்க. ஓகேவா, சோ நமக்கு பவர் ஈக்குவல் டு VRMS ஸ்கொயர் பை R. சோ ரெண்டு எலிமெண்ட்ஸ் கனெக்டா இருக்கு, கரண்ட் சேமா. ரெண்டு எலிமெண்ட்ஸ் சீரிஸ்ல கனெக்டா இருக்கு, கரண்ட் சேமா இருக்கு. ரெண்டு எலிமெண்ட்ஸ் பேரலல்ல கனெக்டா இருந்தா வோல்டேஜ் சேமா இருக்கு. அது நமக்கு தெரிஞ்ச விஷயம் தான். சோ இப்போ வந்து பவர் ஈக்குவல் டு பவர் சப்ளைட் பை 2 lamps. சோ பவர் சப்ளைட் பை 2 lamps ஈக்குவல் டு பவர் சப்ளைட் பை திஸ் வோல்டேஜ் சோர்ஸ் தானே. Power supplied by the 2 lamps equal to power supplied by the 2 lamps தானே. So power equal to நீங்க பாத்தீங்கன்னா power equal to VRMS square by R. Power equal to VRMS square by R. ஓகேவா, so VRMS எவ்வளவு 230 square. R எவ்வளவு, ரெண்டு ரெசிஸ்டன்ஸ் கனெக்ட் சீரிஸ்ல கனெக்ட் ஆயிருக்கு, R1 plus R2. ஓகேவா, சோ வேல்யூ ஆஃப் தி R1 கால்குலேட் பண்ணனும். R1 கால்குலேட் பண்றதுக்கு நம்ம என்ன கொடுத்திருக்காங்க, 230 volts கொடுத்திருக்காங்க, 60 watt பல்போட கொடுத்திருக்காங்க. சோ ரெசிஸ்டன்ஸ் ஆஃப் தி பல்ப் 1 எப்படி கால்குலேட் பண்ணலாம். சோ பவர் ஈக்குவல் டு V square by R நமக்கு தெரியும். சோ R equal to V square by P எனக்கு தெரியும். சோ V square எவ்வளவு, 230 square by P எவ்வளவு, 60. சோ டோட்டல் ரெசிஸ்டன்ஸ் ரெண்டு சேம் ரேட்டிங்னால R equivalent equal to R1 plus R2. So R1 எவ்வளவு, 230 square by 60. R2 எவ்வளவு, 230 square by 60. ஓகேவா, so 2 into 230 square by 60. So power equal to 230, power supplied by 230 volts equal to 230 square by 2 into 230 square by 60, that equal to 30 watts. ஓகேவா, so நீங்க நாலு கீழே பாக்குறப்ப 30 watts இருக்கும், not 120 watts. ஓகேவா, நம்ம இன்னொரு ஆப்ஷன் என்ன கொடுப்பாங்க, 60 வாட்ஸ் கொடுப்பாங்க. அதை எப்படி பார்ப்போம். சோ பவர் ஈக்குவல் டு VI நமக்கு தெரியும். சோ சப்ளை வோல்டேஜ் 230. ரைட். சோ கரண்ட் ரிமைன்ஸ் சேம். சோ கரண்ட் ரிமைன்ஸ் சேம்னா இதுல ஒன்னு எவ்வளவு, கரண்ட் ஈக்குவல் டு பவர் ஈக்குவல் டு VI னால கரண்ட் 230 பை பவர் ஈக்குவல் டு VI இல்லையா. சோ I equal to 60 by 230. So current remains same in the power 230 volts. Current remains same 230 by 60 by 230. 60 by 230. So 230 cancel ஆகும் 60 போட்டுரும். இது absolute wrong. அவன் நீங்க பாத்தீங்கன்னா 60 watts ஆப்ஷன்ல. So இந்த மாதிரி क्वेश्चंस வந்து ஜாகிரதையா டீல் பண்ணணும் फ्रेंड्स. ஓகேவா? So கேட்ல 2 மார்க்ஸ்ல 1 மார்க்ல ஒரு 4 5 3 5 ப்ராப்ளம் இருக்கு. நீங்க ஒரு தடவை அந்த क्वेश्चंस பாருங்க. ஓகேவா? கன்ஃபியூஷன் இல்லாம இருக்கும். ஓகேவா? Let's see the next question. Next question பாத்தீங்கன்னா voltage applied to the RL circuit is 100 cos of 100t plus 30 degree. Circuit resistance கொடுத்திருக்காங்க, inductance கொடுத்திருக்காங்க. At steady state என்ன கேட்டிருக்காங்க? At steady state the maximum amplitude of the current என்னன்னு கேட்டிருக்காங்க. இங்க உங்களுக்கு எல்லாம் தெரிஞ்சிருக்கும். ஸோ நான் சொல்ல தேவையில்லை. ஒரு நெட்வொர்க் கொடுத்திருந்தா, ஒரு RLC நெட்வொர்க் கொடுத்திருந்தா இதுக்கு சைனசாய்டல் சிக்னல் அப்ளை பண்ண உங்களுக்கு சப்போஸ் ஃபார் எக்ஸாம்பிள் V of t equal to Vm sin omega t நான் அப்ளை பண்றேன். ஸோ V of t Vm sin omega t அப்ளை பண்ண உங்களுக்கு அவுட்புட் வந்து என்ன வரும்? some x into Vm sin of omega t plus 5. ஓகேவா? ஸோ என்ன சேஞ்ச் ஆகுது உங்களுக்கு? இங்க x into Vm சேஞ்ச் ஆகுது, magnitude சேஞ்ச் ஆகுது, phase plus or minus 5. So phase வந்து add ஆகலாம், separate ஆகலாம், depend upon the RLC components. ஓகேவா? So ஒரு RLC நெட்வொர்க் நீங்க சைனசாய்டல் சிக்னல் கொடுத்தா உங்களுக்கு சைனசாய்டல் அவுட்புட் தான் வரும். உங்களுக்கு சைனசாய்டல் சிக்னல் கொடுத்தா உங்களுக்கு சைனசாய்டல் அவுட்புட் தான் வரும். ஓகேவா? சைனசாய்டல் அவுட்புட் தான் வரும். There is no change in the frequency. So நீங்க பாத்தீங்கன்னா sin omega t கொடுத்தா உங்களுக்கு sin omega t தான் வரும். So இங்க omega t கொடுத்து இங்க 3 omega t வராது. இங்க 2 omega கொடுத்து இங்க 4 omega வராது. ஓகேவா? So whatever the frequency you have given to the RLC network, that frequency will come out from that RLC network. So உங்களுக்கு 1 mark questionல வர வாய்ப்பு இருக்கு. Suppose if I given the sinusoidal signal to the some network, some circuit. So what are the possibilities of the output? What are the possibilities of the output? And which statement is incorrect? The amplitude will remains. The amplitude changes. Sorry, first option amplitude changes, phase changes, frequency changes. Okay, D, all the above. Which statement is incorrect? Frequency changes is the incorrect statement. Okay, so இப்போ பாத்தீங்கன்னா RL circuit கொடுத்திருக்காங்க. இதுக்கு வந்து 100 cos of 100t plus 30 degrees. So this is of 80 ohms and 0.6 Henry. Okay, so I equal to V by Z. Okay, so current supply voltage put in the response current. Okay, this is input excitation, the response has a change in magnitude and phase only. There is no change in the frequency. So what is the response here? Whenever supply voltage is given, what is the response here? The current. So the response is current I equal to V by Z. So 100 cos of, so let's take V by Z is how much? 80 plus J omega here. Omega is how much? 100 into 0.6. So 6 by 10. So V by 80 plus J 60. Okay. So what I do here is V by root of 80 square plus 60 square at an angle minus tan inverse of 60 by 80. So what you get the output here? 100 by root of 80 square plus 60 square sin of cos of 100t plus 30 minus tan inverse of 60 by 80. So this will be the answer. So what he asked, the maximum amplitude. This is suppose V of t is Vm sin omega t. So another maximum V max. This is the maximum amplitude. Vm is the peak value or amplitude. So what is the maximum amplitude here? 100 by root of 80 square plus 60 square. So this will be the answer. So everyone can calculate பண்ணி comment box ல கொடுங்க. Next question. So next பாருங்க இந்த question. கொஞ்சம் டிஃப்ரெண்டான क्वेश्चन, expected model 2 marks க்கு expected model. So என்ன கேட்டிருக்காங்க, for this circuit he asked the time constant of the below circuit, time constant of the circuit. For this circuit he asked the time constant of the circuit. So இந்த question பாருங்க, time constant னா இப்போ வரைக்கும் நம்ம dependent source இல்லாம calculate பண்ணிருக்கோம். இந்த dependent, இது dependent source. எது dependent source? இது very important question. இது வந்து dependent source. இது வந்து dependent source. இது வந்து dependent source. ஓகேவா? So actually வந்து time constant equal to L by R இல்ல 1 by RC calculate பண்ணுவோம். இங்க பாத்தீங்கன்னா இந்த சர்க்யூட்டுக்குள்ள 3VC current போகுது. இந்த சர்க்யூட்டுக்குள்ள 3VC current போகுது. ஓகேவா? ரைட்டா? So நான் இப்போ இங்க இந்த கெபாசிட்டர் கொண்ட நான் என்ன பண்றேன், ஓம்ஸ்ல அப்ளை பண்றேன். So IC equal to C into dVC by dt. IC equal to C into dVC by dt. So what is the current flowing through this capacitor? I am applying Ohm's law across this capacitor. I am applying Ohm's law across this capacitor. Okay, wow. So what is the current through the capacitor? 3VC. So 3VC. What is the current through the capacitor? 3VC. Right. So 3VC equal to C into dVC by dt. Okay. So dVC by dt into C minus 3VC equal to 0. Equal to 0. Right. So நான் இப்போ என்ன தப்பு பண்ணேன், இங்க பாருங்க. Actually the current flowing through the passive elements always from plus to minus, but here the current flowing from minus to plus. The current is flowing here like this. The dependent source current is flowing like this. So minus IC minus 3VC plus 3VC will come into picture. So dVC by dt into C plus 3VC equal to 0. So dVC by dt plus 3VC by C equal to 0. So this is something look like a differential equation. D plus 3 by C into VC equal to 0. VC of t equal to K into e power minus 3 by Ct. Okay. VC of t equal to V0 into e power minus t by tau. What is tau? Compare this equation. Tau equal to C by 3. Time constant equal to, right or not? What is C here? 10 millifarads. 10 milli by 300. 10 by 1000 into 3. So 10 cancel. 1 by 300 seconds. So this is something different problem. So kindly carefully observe this problem and practice this problem, friends. Time constant of the below circuit. நான் இப்போ வரைக்கும் நம்ம வந்து some RL சர்க்யூட்டோ RC சர்க்யூட்டோ கொடுப்பாங்க. நம்ம என்ன பண்ணுவோம், அந்த ரெசிஸ்டன்ஸை எடுப்போம், செப்பரேட் பண்ணுவோம், இண்டக்டன்ஸை செப்பரேட் பண்ணுவோம், ஈக்குவலன்ட் ரெசிஸ்டன்ஸ் ஈக்குவலன்ட் இண்டக்டன்ஸ் கால்குலேட் பண்ணுவோம். Similarly in case of capacitance, you remove the resistance, you have to remove the capacitance, and you have to separately apply equivalent resistance, equivalent capacitance. For the RL circuit, time constant is L by R. For RC circuit, time constant is RC. Right. So carefully practice more problems, friends. Okay, next question. So in the question paranga, friends, somewhat different question. The voltage at the terminal of a battery, the voltage at the terminals of a battery drops from 18 volts to the 16 volts. நீங்க பாத்தீங்கன்னா for example if I have a battery, initially 18 volts இருந்துச்சு, அதுக்கப்புறம் it drops to 16 volts. If drops to 16 volts, when current 0.5 amperes drawn. So initial 18 volts இது இருந்துச்சு. Initial 18 volts இருக்கிறப்ப நான் ஒரு ரெசிஸ்டன்ஸ் கூட கனெக்ட் ஆகிறப்ப லோட் கிட்ட எவ்வளவு இருக்கும்? 18 voltsல இருக்கும். So question carefully observe பண்ணுங்க. So ideal voltage source consider பண்ணீங்கன்னா whatever the current voltage, the source voltage remains constant. Whatever the voltage, source voltage, that remains constant at the terminal voltage. Whatever the voltage at the source, is equal to terminal voltage. So voltage is dropping means he is considering the practical voltage source. He is considering the practical voltage source. So initial 18 volt இருக்கு. இங்க suppose RS வச்சா உங்களுக்கு terminal voltage எவ்வளவு ஆகும்? V equal to E minus I into RS. So E எவ்வளவு? 18 volt கொடுத்திருக்காங்க. I எவ்வளவு? 0.5 amperes. RS தெரியாது. And V எவ்வளவு? 16 வோல்ட்டுக்கு வந்திருக்கு. So RS எவ்வளவு ஆகும்? RS எவ்வளவு ஆகும்? 18 minus 16 by 0.5. So 2 by 0.5. 2 into 10 by 5. 5 2s. That equal to 4 ohm. Okay va? So அப்ப 18 volt. This is a 4 ohms for maximum power RL. For maximum power RL equal to 4 ohms. What is the maximum power? Maximum power equal to V square by 4 RL. Okay va? So V square eவ்வளவு? 18 square 4 into RL எவ்வளவு? 4. Calculate பண்ணி comment box ல போடுங்க. So next question பாருங்க. 3 impedance Z at angle 0, Z at angle 90, Z at angle minus 90 is connected in delta configuration. So what is the magnitude of the impedance in equivalent star configuration? In equivalent star configuration. So he asked, I have a delta. So this is of Z at angle 0, this is Z at angle 90 degrees, this is Z at angle minus 90 degrees. So equivalent star, how you solve this question? எப்படி solve பண்ணுவீங்க? So Z equivalent, actually நீங்க பாத்தீங்கன்னா suppose if you have equivalent resistance, if I convert a star to delta, if I initially have a star network each having a resistance R. If I convert to delta, it increases to 3 times the resistance. If I convert from star to delta, it have a resistance of the something like have a resistance. It increases to 3R. If I have a delta to star, if I have a resistance R, if I change to star, same resistance, then you have R by 3. Okay, this you know. But here given differently, Z at angle 0, Z at angle 90, Z at angle minus 90. Connected in delta configuration. What is the magnitude of the impedance in equivalent star? So if at all it is an R in delta, if you convert to the star, it is reduced by 1/3. It is reduced by 1/3. இது நமக்கு தெரிஞ்சதுதான். So delta la vandu na resistance R vacha, star la vandu 1/3 of the resistance. Suppose star la resistance vacha, delta la vandu 3 times of the resistance. Okay va? So let's see. So delta la vandu let's take delta la Z at angle 0, Z cos 0 plus J sin 0. Cos 0 is 1, sin 0 magnitude. You have remained Z at angle 90. Z at angle cos 90 plus J sin 90. You get cos 0 1, cos 90 0. So JZ. Z at angle minus 90. Cos 90 minus J sin 90. So Z at angle minus JZ. Right. So I have here Z, I have here J at angle 90, here minus J at 90. So directly எழுதலாம். So so Z at angle 90 means JZ, Z at angle minus 90 means minus JZ. Okay. So how you convert into star? Suppose if I consider this Z into JZ, I want this term, this element z into jz by z plus jz minus jz. You get cancel, and 1z cancel. You get jz. If I consider this jz into minus jz minus jz plus z. Okay, so j square is minus 1 minus z. If I consider this, you get z into jz, jz minus jz plus jz minus jz cancel. You get z. You get z. So magnitude of the impedance in equivalent torque, this is magnitude is z, this magnitude is z, this magnitude is z. So answer is you get z only. If you convert to the star, you get only z. So let's see the next question. In series RLC circuit, frequency of the source kept below the resonant frequency, the power factor of the circuit. So in series RLC circuit, we know that impedance is minimum, current is maximum, it is a voltage magnified circuit. Something you have to know, okay, voltage magnified circuit. So quality factor equal to 1 by r root of LC, 1 by r root of L by C, and omega naught L by R, 1 by omega naught of C. Okay, so quality factor equal to omega naught by quality factor equal to bandwidth equal to omega naught by quality factor. If you solve this, you get R by L, bandwidth equal to R by L. How you get omega naught equal to 1 by root of LC, quality factor equal to 1 by R root of LC, 1 by R root of L by C. You solve this, you get R by L. Okay, so and impedance is minimum. So this is Z. By varying frequency, you get impedance is minimum. By varying frequency, you get the current is maximum. This is resonant frequency. So below resonant frequency, you have a leading power factor. Above resonant frequency, you have a lagging power factor. And if you see this, this is bandwidth. Bandwidth is 1 by root 2 times. 1 by root 2 times of this is maximum value, I naught equal to V by R. So at resonance, you don't have a reactive components. Suppose if I have R, L, C circuit, okay, so supply voltage. At resonant, I have only I equal to V by R. So this is the maximum current. At resonant frequency, you have a maximum current that equal to V by R. Okay, so below resonant frequency and you have a leading power factor, above resonant frequency you have a lagging power factor. So this can be simply, you can observe Z equal to R plus J omega L plus 1 by J omega C, that equal to R plus J omega L minus 1 by J omega minus J by omega C, right? So you can see here, this you can நீங்க வந்து மகப் பண்ண தேவையில்லை. Z equal to let's see here, Z equal to R plus J omega L plus 1 by J omega C. Okay, omega C. So I am giving the Z frequency. So Z equal to R. First of all, I am considering R. So if I take R, I don't have XL and XC components that remain, that will give parallel to the XS. For whatever the frequency you have a resistance is constant. For whatever the frequency, resistance value is constant. If you draw XL for varying frequency, so omega equal to 0, omega XL equal to 0, omega equal to infinity, XL equal to infinity. Something you get like this, varying like this. Okay, you get something. Omega L equal to 0, you get XL equal to 0, XL equal to infinity, you get something like this. For omega 1 by omega X equal to 1 by omega C, omega equal to 0, you get X equal to infinity. and omega equal to infinity, you get x equal to 0. So this is the impedance curve, Z for Z and omega for weighing frequency, you get this. So you have, this is leading power factor, and this is lagging power factor, and this is resonant frequency. So below resonant frequency you have a leading power factor. Okay, so நீங்க வந்து மர்க் பண்ண தேவையில்லை. So little brain concept apply பண்ணா. Okay, next question. So இந்த question பாருங்க, very different question. ஓகேவா? So சின்ன question எல்லாம் பார்க்காதீங்க, கொஞ்சம் டெப்த்தாவே போங்க, then only you can get confident. ஓகேவா? simple questions எல்லாம் கொடுக்க மாட்டாங்க friends, so அதை அவாய்ட் பண்ணுங்க. ஓகேவா? ஸோ சின்ன இன்ஸ்டியூட் காரங்க எல்லாம் சின்ன கொஸ்டின்ஸ் சொல்லிட்டு அதை வச்சு அட்மிஷன்ஸ் எடுக்கிறாங்க. ஸோ டோன்ட் believe all this. Okay, so let's see here, the value of the R for which energy stored in the capacitor and energy stored in inductor are equal in steady state. The value of the R in which energy stored in the capacitor. Question நல்லா பாருங்க, the value of the R, he asked the value of the R. Okay, the value of the R for which energy stored in the capacitor and inductor equal to steady state, are equal, energy stored in the capacitor. So what is energy stored in the capacitor, friends? Energy stored in the capacitor on the half CV square. What is energy stored in the inductor? Half Li square. இது தெரிஞ்சதுதான், half Li square. தெரியுமா தெரியாதா? நமக்கு தெரியும். ஓகேவா? ஸோ இப்ப கொஸ்டின்ல என்ன கண்டுபிடிக்கணும்? at steady state. நல்லா பாருங்க, at steady state what happens to inductor? Short circuit. What happens to capacitor? Open circuit. ஸோ உங்களுக்கு பாத்தீங்கன்னா இது 10 ஆம்பியர் வந்திருக்கு. ஸோ இது ரெசிஸ்டன்ஸ் and இது ஓபன் ஆயிருக்கு, and you have inductor is short circuited, and you have a 3 ohms, and this is IL of infinity, and this is plus VC of infinity. Steady state na VC of infinity, steady state la dhaan. Okay ba? So from this, what happens to IL of infinity? Let's see here, IL equal to so இங்க பாருங்க, IL equal to IL of infinity equal to VC of infinity by R. VC of infinity by பாருங்க, IL of infinity, the current that flows through the resistance, IL of infinity. This terminal is this terminal, VC of infinity. So IL of infinity equal to VC of infinity by R. That equal to IL equal to VC by, in steady state IL equal to VC by R. So energy stored half CV square equal to half Li square. Okay, half CV square equal to half L. I is how much? I is nothing but current through the inductor. VC square by R. Half CV square, half CV counter, half IL square. Confusion, okay. So I will get VC square cancel, half cancel, R equal to, sorry, inge parunga, IL square equal to VC square by R square. So R square equal to L by C, R equal to root of L by C, L level 6 millihenry, 240 microfarads. You calculate and put the answer in comment box. Okay, so this is energy stored in the capacitor equal to energy stored in inductor at steady state. At steady state, inductor short circuit, capacitor open circuit. If I know the relation between the IL and VC, then the answer is simple. That energy stored in the inductor is equal to the energy stored in the capacitor. Energy stored in the capacitor. Okay, let's see the next question. So see this question, the total harmonic distortion of amplifier should be reduced from 8% to 2% by using 5% feedback. The gain of the amplifier with the feedback. feedback. So நமக்கு என்ன தெரியும்? So negative feedback and சொன்னாங்கன்னா negative feedback intentionally positive feedback கொடுத்தா okay. Okay, so we know that a closed loop gain equal to a by a open loop gain by 1 plus a beta. தெரியுமா தெரியாதா? a closed loop gain equal to a open loop gain by open loop gain that equal to into beta. So உங்களுக்கு என்ன தெரியும் பாருங்க, இது g negative feedback apply பண்ணா h g by 1 plus gh தானே. So g வந்து open loop gain, a closed loop gain equal to a open loop gain plus 1 plus a open loop gain into beta. Similarly, total harmonic distortion equal to total harmonic distortion open loop, this is total harmonic with closed loop equal to total harmonic distortion with open loop 1 plus total harmonic distortion with open loop into beta. Sorry, total harmonic distortion closed loop equal to, I am extremely sorry, total harmonic distortion with closed loop equal to total harmonic distortion in the open loop by 1 plus a beta. Okay, so 8% open loop and reduce it to 2% by closed loop by using feedback. So initially open loop total harmonic distortion, closed loop 2% கம்மியாச்சு by using 5% feedback, by using 5% feedback. Right. So total harmonic closed loop வந்து 2 by 100, open loop வந்து 8 by 100 plus 1 by a beta, 1 plus a beta, 100 cancel ஆச்சு. So 1 plus a beta equal to 4. Right. So a beta equal to 3. A beta your feedback on 5 by 100 equal to 3. So a equal to 3, there is 3. A equal to 3 into 100 by 5, 520 is that equal to 60, gain equal to 60. So we know that gain and the open loop gain, open loop gain. So closed loop gain, the gain of the amplifier with feedback, that is closed loop gain. Gain of the amplifier with feedback is a closed loop gain. So closed loop gain equal to open loop gain 60 plus 1 plus a beta open loop gain 60, beta 5 by 100. Okay, so 100, 5 2s 3s 60 by 1 plus 3. So it's all this, put the answer in the comment box. So let's see some model questions in another video. Okay, so don't fear of that questions friends. Okay va, neenga பயப்பட தேவையில்லை, practice பண்ணா ஈஸியா வந்துரும். Okay va, so next video some more questions பார்ப்போம். Okay va, with different questions. Easy questions எல்லாரும் பண்ணுவாங்க easy questions. Okay va, easy questions எல்லாரும் பண்ணுவாங்க. அது நான் சொல்லி உங்ககிட்ட லைக்ஸ் வாங்குறதோ வியூஸ் வாங்குறதோ எனக்கு தேவையில்லை, and comment வாங்குறது தேவையில்லை. I want to be deliver the concept oriented questions, concept oriented with different questions. Okay, let's see some more questions. Hi friends, welcome to Tneb Gates Education. Sorry friends, I am extremely sorry, health problem நால என்னால வீடியோ அப்லோட் பண்ண முடியல. சில ஃப்ரெண்ட்ஸ் மெசேஜ் பண்ணியிருந்தீங்க, சில ஃப்ரெண்ட்ஸ் மெயில் பண்ணியிருந்தீங்க. எனிவே I am extremely sorry, இனிமே அப்படி டிஸ்கண்டினியூ ஆகாது. ஸோ I am sorry for the health problem நால தான், வேற இஷ்யூஸ் ஒன்றும் இல்லை. So let's start the problem. The following circuit represents an ideal transformer. The value of the impedance X. Question carefully படிங்க friends. The value of the impedance X. The value of the impedance X. What is the value of the impedance X? We know that Z equal to R plus JX. Z equal to R plus JX. He directly asked the value of the impedance Z equal to X. Z equal to X. That means here X value only. I have to find X value only. Right. Okay. To make the supply power factor unity. To make the supply power factor unity. Okay. Right. Okay, sir. The load வந்து 5 kVA, 500 volts, 0.8 power factor lag கொடுத்திருக்காங்க. So நமக்கு என்ன தெரியும்? So இப்போ இந்த லோடு வந்து either இங்க transfer பண்றேன் or இந்த total வந்து இங்க transfer பண்ணணும். ஏதோ ஒன்னு அங்கிட்ல இருந்து இங்க transfer பண்ணணும், இங்கிட்ட இருந்து அங்க transfer பண்ணணும். If I know that concept, then it is very easy to make the supply power factor as unity. Okay. Sir, இப்போ வந்து அங்க லோட்ல வந்து 5 kVA 500 volts 0.8 பவர் ஃபேக்டர் லேக் கொடுத்திருக்காங்க சார். இம்பிடன்ஸ் கொடுக்கல சார், ரியாக்டன்ஸ் கொடுக்கல சார். நான் எப்படி சார் ட்ரான்ஸ்ஃபர் பண்ண முடியும்? எனக்கு டிரான்ஸ்ஃபார்மர்ல என்ன தெரியும் சார்? ரியாக்டன்ஸ் ட்ரான்ஸ்ஃபர் பண்ண முடியும் சார். பிரைமரி டு செகண்டரி டு பிரைமரி. இம்பிடன்ஸ் ட்ரான்ஸ்ஃபர் பண்ண முடியும் சார். ரெசிஸ்டன்ஸ் ட்ரான்ஸ்ஃபர் பண்ண முடியும் சார். வோல்டேஜ் ட்ரான்ஸ்ஃபர் பண்ண முடியும் சார். ஆனா லோடு வந்து இப்போ வந்து 5 kVA 500 volts 0.8 பவர் ஃபேக்டர் கொடுத்திருக்காங்க சார். நான் எப்படி சார் ட்ரான்ஸ்ஃபர் பண்றது? எப்படி சார் ட்ரான்ஸ்ஃபர் பண்ணும்? சரி சார் பார்ப்போம். Z equal to V by I voltage per current. ஓகே, நான் என்ன பண்றேன்? வோல்டேஜோட மல்டிப்ளை பண்றேன், ரைட்? வோல்டேஜ் ஸ்கொயர் பை VI, வோல்டேஜ் ஸ்கொயர் பை வோல்ட் ஆம்பியர். So Z equal to 500 into 500 by into 500 into 5000 divided by 5000. So இங்க ரெண்டு 0 cancel ஆகுது, இங்க ஒரு 0 5 cancel ஆகுது. Z equal to 50. Okay, so இப்போ பாத்தீங்கன்னா so plus or minus volt something voltage is given 2 ohms. இந்த பாக்ஸ்ல reactance எவ்வளவுன்னு கண்டுபிடிக்க சொன்னாங்க. ஓகே, இந்த பாக்ஸ் வந்து Z by K square. இந்த பாக்ஸ் இப்போ நான் செகண்டரியில இருந்து பிரைமரி ட்ரான்ஸ்ஃபர் பண்ண Z by K square. Z என்ன தெரியும்? 50. சம்திங் பவர் ஃபேக்டர் இருக்கு, பார்ப்போம். K square எவ்வளவு? 1/10 whole square, ரைட்? K டிரான்ஸ்ஃபர்மேஷன் ரேஷியோ உங்களுக்கு தெரியும். ஓகே, சோ என்ன பார்ப்போம்? Z equal to 50 னா இது மேக்னிடியூட். பவர் ஃபேக்டர் வந்து 0.8 கொடுத்திருக்காங்க. இப்போ Z by 50 by 1/10 whole square போட்டு நீங்க கால்குலேட் பண்ணா x வருதா? வராது. Z ல உங்களுக்கு என்ன இருக்கு? R வேல்யூ இருக்கு, x வேல்யூ இருக்கு. R வேல்யூ இருக்கு, x வேல்யூ இருக்கு. சார் இதுல R வேல்யூ x வேல்யூ வந்தா இதுல x வேல்யூ சார் எப்படி சார் கால்குலேட் பண்ண முடியும்? क्वेश्चन அது. எதுக்கு சார் இதுல R வேல்யூ x வேல்யூ கால்குலேட் பண்றீங்க? அவன் என்ன क्वेश्चन கேட்டான்? To supply power factor is unity. Supply power VI relation voltage and the angle between the supply voltage and current is unity means power factor is unity means it should be in phase. That means total circuit should be resistive. Total circuit should be resistive. So இப்போ நான் இதுல வந்து R plus JX something வந்துச்சு, இங்க minus JX வச்சா total is resistive ஆயிப்பேருமில்ல? ஓகேவா? சோ இப்போ R plus JX இங்க கால்குலேட் பண்ணாலே போதும். இங்க minus JX வரும். அந்த X வேல்யூ தான் ஆன்சர். அது கால்குலேட் பண்ண சொன்னது X தானே? புரிஞ்சுச்சா? இப்போ பாருங்க. சோ 50 Z வந்து 50 வந்திருக்கு. cos 5 எவ்வளவு? R by Z. sin 5 எவ்வளவு? X by Z. தெரிஞ்சதுதான். ஓகேவா? cos 5 0.8, R தெரியாது, Z 50, R equal to எவ்வளவு? 50 into 0.8. sin 5 எவ்வளவு? X by Z. X எவ்வளவு? தெரியாது. X கண்டுபிடிங்க. X equal to 50 into cos 5 0.8 னா sin 5 0.6. கரெக்ட். ஓகேவா? So 50 into 0.8 எவ்வளவு ஆகுது? So 50 into 8 by 10, 10 5s, R equal to 40. X equal to 50 into 6 by 10, 10 5s, 30. ஓகேவா? So R Z equal to R plus JX that equal to 40 plus J30. இங்க transfer பண்ண 4 plus J30 by K square. K square எவ்வளவு? 4 plus J30 into 100. So you get 4000 plus J3000. Okay. So இப்போ பாருங்க. So this z by k square is a 4000 plus j 3000, correct? So I want to make this applied power factor as unity means I want to cancel this reactance. I want to cancel this reactance means I want to place here minus j 3000. So what is the value of the x? 3000. So this value of the element is minus j 3000, or x equal to option minus j 3000 kurta minus j 3000, or what is the x value means 3000. Are you able to understand or not? So to make this applied power factor is unity, I want to make the circuit purely resistive. So to make the purely resistive, what I have to do is, if I make plus j 3000, to compensate that j plus j 3000, I make minus j 3000, then I get the unity power factor. So what is the value of the x here? 3000. If he asks what is the value of the total that element minus j 3000. Hope you understand this question. I expected 2 more questions to your political lecture exam. Okay, next question. See this question. A single phase transformer having 200 turns is excited varying flux 10 sin omega t. Supply frequency is 60 Hz. The value of the voltage induced per turn. The value of the voltage induced per turn. So question carefully observe பண்ணுங்க. So if I am in the examination hall, what I do simply here is E equal to 4.44 F5 turns. Okay, so this I do. What I know, 4.44 I know, F I know, 65. Okay, 5. I don't know. He is given 10 sin omega t. I don't know. Voltage induced per turn. So I make this E per turn. So what I have to do, flux. Okay. So this will be the confusion over the student in the examination hall. What do you have to do? So some students, what they do like this now, E equal to n into d phi by dt. So he is given in phi 10 sin omega. Okay, so we know that phi equal to phi max sin omega. Phi equal to phi max sin omega. So what is the phi max? He is given 10 sin omega. So phi max is 10 here. Phi max is 10 here, right? So induced per turn, induced EMF equal to 4.44 F5 turn. Induced EMF per turn is 4.44 F5 max. So 4.44 I know, F is how much? 60. Phi max is how much? 10. So is anything is there? Okay. So what we do mistake here? You forget about milli here. Flux is given in milliweber. You forget about this. The common mistake what we do in the examination hall. So 4.44 into 60 into 10 by 1000. So these two cancel. So 444 divided by 100 into 10 into 6. Okay. So this is 6 fours. You solve this 6 fours 24, 6 fours 24 to 6 fours 24 to 6 fours 24, 6 fours 24 to 26, 6 fours 26. So by 1000. So 2.664 is the answer. 2.664 is the answer. So this is the solution. Hi friends, welcome to KMA Gate Education. So let's start another video. First question is more relay is normally used for the protection of long transmission line. Whereas long transmission line, whereas impedance relay for medium transmission line, whereas reactance relay for short transmission line. So if you see the more relay characteristics, it passes through the origin. Okay, And if you see medium transmission line, it has a circle centered origin, whereas in short transmission line you have an axis, you have a line parallel to the x-axis, okay. And you comment in the comment box that which relay has a least affected by power surges, which relay is least affected by power arc resistance. So you see that, and you see the topic of the distance relay, and one revision is completed. One time revision is completed. So one time you see, for that purpose only I given the blank to comment in the comment box. Okay. Let's see the next question. So you see the next question. A lightning arrestor is usually located nearer to the transformer. Actually, in the substation, the first element and the last equipment, is the lightning arrestor. You have to remember this. Okay. So to protect the transformer, lightning arrestor is used. And the lightning arrestor is the first equipment and last equipment of the substation. You have to also remember this. Lightning arrestor is a first and last equipment of the substation. Okay. And lightning arrestors are used to protect the terminal equipments of the power substation. Okay. So he will ask that a lightning arrestor is usually located near the transformer, and which is the first equipment and last equipment of the substation. Which equipment is used for the protection of the substation? For the first last equipment means for the protection of the substation, that will be the lightning arrestor. You have to remember this. Okay. Next. So here the question is given: an electric iron is rated for 230 volts. 400 watts, 50 Hz. The voltage rating 230 volts refers to. So if he asked in terms of it is a line voltage, line RMS voltage, line peak voltage, or phase RMS voltage, or phase peak voltage. Okay. So this 230 volts. If the rating is given, this rating is 230 volts, is always line to line RMS voltage. Okay. Line to line RMS voltage. Right. So what is the relation between the maximum and RMS voltage? Vmax equal to root 2 into Vrms. You have to know this. Vmax equal to root 2 into Vrms. And we design insulation on phase manner. We design insulation on phase voltage. Based on the phase voltage. Okay. So what is the reference for designing insulation? Means switched voltages. Okay. Switched voltage means there is surge voltages. You have two types of surge voltages: external over voltages, internal surge voltages. So we design insulation based on the internal surge voltages, switched voltages. Okay. Switched voltages depend upon phase voltage. Okay. Phase manner. We will not take line to line RMS voltage. We design insulation based on the phase voltage. Okay. We design insulation based on this phase voltage. And what is the reference for the design of the insulation? Means that is a switched voltage. So you have to remember this. The given the voltage, whatever the voltage that is coming from the substation, that is a line to line RMS. If he given 230 volts, means that is a line to line RMS voltage. If he want to design the insulation based on the phase manner, that is a phase voltage. So what is the reference voltage? It is not a line to line RMS voltage. For the design of insulation, you have to take a switch voltage. What is the switch voltage? Surge voltage. You have two over voltages, that is external over voltages and internal over voltages, that is switched voltages. So external over voltages by grading method, you have to protect the external over voltages by grading method. You have a guard wire, okay, made up of zinc oxide, and internal over voltages, non-shielding methods. You have shielding methods and non-shielding methods. You keep revised one time. So what are the shielding methods? What are the non-shielding methods? What is an impulse ratio? which has a high, what is the impulse ratio for solid sphere, something points out there. You have to revise one thing. Okay, so what is impulse ratio? What is impulse ratio for solid and dielectric? Okay, and what is the shielding method? What is a non-shielding method? For shielding method, arc is drawn. Arc is formed between the ground and insulator and ground. Arc is not formed between insulator and ground. So for which method arc is formed, for which method arc is not formed, you have to see all the points for 1 mark. Okay, so friends, one time you have to revise the topic of the insulation breakdown. Insulation breakdown. Some in some textbook, over voltages. Okay, over voltage. We have to see this. Next question. So let's see this question. The capacitance measured between any two cores of the 3-core cable with depth at least 3 microfarads. The capacitance per phase. The capacitance per phase. See carefully the question. The capacitance measured between any two cores of the 3-core cable with depth at least 3 microfarad. The capacitance per phase. So do one thing. You see the topic of the cables and complete the syllabus of the core cable and try to solve this question. In the next video, I definitely give the solution to this video. Meanwhile, you complete the topic of the cable and solve the previous IES questions of the cable and previous gate 1 mark questions of the cables. Okay, you complete the previous IES and gate questions of the cable and try to solve this. If not at all you are not able to solve the question, comment on the comment box. Then definitely I will give the solution in the next video. So complete the syllabus. Okay, cables you complete the syllabus. Definitely I will give the solution in the next video. So let's see the next. So this question is also dielectric loss is proportional to the He's asked frequency or frequency square or frequency cube or 1/4 of the frequency. So dielectric loss is proportional to. He asked. The option is here: frequency, B frequency square, C frequency cube, D root frequency, root of frequency. So here is the option given. So this topic is also comes under cable. Try to solve this. Okay, try to solve it. So this is simple. Okay. So for example, I represent the dielectric with a capacitance. I represent the dielectric with a capacitance. Okay, so I have an imperfect resistance. Here. So this is the practical representation of the dielectric. Okay, so here what I do, so if I have a supply voltage here, current here, I have IC and IR. So voltage is common, I take the reference like this. Voltage is common, I take the reference like this. So one current is in phase with IR. Current is in phase with voltage, that is IR. One current is in leading the voltage by 90 degrees. Okay, IC. I just going by network analysis. So this is the practical representation of the dielectric. That is the capacitance is parallel with resistance. Okay, so I have a voltage. Voltage is common. I taking the voltage as a reference, and current through the resistance is in phase with voltage. Okay, current through the resistance, and current through the capacitance is leading the voltage. So resultant current I have like this. This is the resultant current I. So I equal to IR plus IC. So basic network analysis. You go from network analysis. Okay, you can analyze any electrical subject. Okay, I equal to IR plus IC. Right. So what is the angle between the voltage and current is the power factor. So what is the angle between the voltage and current? That is a power factor. The angle between the resultant current and the capacitor is a dissipation angle, that is delta. Okay, you see once careful, you can understand. Okay, so I am giving just idea of that. Delta. Dielectrics. Dielectric loss is nothing but a tan delta. Dielectric loss is nothing but a dielectric loss. So actually, let dielectric loss tan delta. So it is proportional to the frequency square. You have a derivation. It is very simple derivation. Once you see the cables, then easily understand. Okay. Actually, what is power here? Power equal to V I cos phi. V I cos phi. So let's see here. Power equal to V I cos phi. I can write V into IR. IR equal to I cos phi. Right or not? So you project the angle. So what is the x-axis component? I cos phi. That equal to IR. Okay. So but I want dielectric loss. Dielectric loss depends upon this angle delta. Okay. The angle between IC and I is delta. That represents the dielectric loss. Okay. What is the tan delta? What is tan delta here? Tan delta equal to IR by IC. This is IR. This is IR. You apply tan delta. IR by IC. Sin by cos. What is IR now? V equal to IC into tan delta. What is IC? V by XC. Tan delta. V square omega C tan delta. XC equal to 1 by omega C. If I go upwards, V square omega C delta. Okay. So omega is nothing but 2 pi F. So dielectric loss is proportional to frequency. So I want to find the loss in terms of delta. I find that. So power is finally proportional to frequency. So you have to see, you see one time, then you are not able to remember this. Then you can easily solve the question. You can easily solve that answer. Okay. So network analysis is the basis for any subject in electrical machines. Okay. Next question. So let's see the next question. Different types of insulators used for transmission lines. What are the different types of insulators used for transmission lines? Pin type insulator, suspension type, and shackle type insulator, and strain type insulator. So you see what is true. Okay. So you see one insulator's topic. What is the pin type? So you don't see in depth of that insulators. So what is the pin type insulator? And each insulator is defined suspension insulator, and a pin insulator is used for up to how much voltage. Suspension insulator beyond 11 kV, and each insulator is defined for 11 kV. How much voltage is used for suspension insulator? And shackle insulator and strain insulator. When we use strain insulator, where the suspension insulator is in horizontal or vertical, where strain insulator is used horizontal or vertical, at tower end, at dead end power, at dead end turning point, that is bridge crossing, at that time, which type of insulator used. Okay, so string efficiency. So these are the info points. So what I am telling here is, you see the cables, you see the insulators of previous gate questions, previous IES questions. So only see the gate questions of 1 mark. You don't you need not to see 2 marks question. Okay. If at all you see the 2 marks question, that you can simply you can solve the problem. If it is difficult, it is not given in the TRB Polytechnic exam. If it is handy, you can just simple by making simply you can solve the question. Then you solve that problems. Okay. So you have to complete the cables, and you have to complete the insulators. You have to complete the insulators. These 2 topics you have to complete, and comment the answer in the comment box. Okay. Previous IES questions, previous grade questions. Okay. 2 topics will be completed. 2 topics will be completed, and see protection also. See switch gear in protection also one time. So you have to complete 3 topics. You have to complete the 3 topics: switchgear protection and cables and insulators of previous IAS and gate questions. IAS and gate questions. Okay, and then comment in the comment box. You have completed the syllabus of the. Simply, if you revise this, then you can easily can remember all the questions. Okay, you keep revise one or 2 times. Simply revise 1 or 2 times of IS and gate questions of this cable protection and insulators, because these are theory subject. The switchgear protection is a theory subject, and circuit breaker is a theory. This is insulators is a theory subject, cable is a theory subject. Okay, so you can't do so much problems in that. Okay, so let's see next questions in another video. Thank you, friends. Hi friends, welcome to Tneb GATE Education. Let's see some important questions which can be expected for TRB Polytechnic Nature Exam and Tneb from electrical machines and measurements. The first question is, the two DC series motors are connected in series to produce a torque. If the motors are connected in parallel, the torque produced will be. Let's see, I have two series motors, two DC series motor. I am connected in series. Okay, I am giving supply voltage V and I have a current I. If the same series motors are connected in parallel, if the same series motor are connected in parallel, the torque produced will be. Assume power drawn is constant, that is V into I constant, driven power equal to Vi equal to constant, right? So you have a supply voltage here. What happens, you see here, whenever the supply voltage is given, this will be the current I. Here supply voltage is given, the current in each series motor will be half whenever it is in parallel. Okay, what we know here is torque equal to proportional to phi into Ia, torque equal to K into phi into I. So let torque equal to K into phi into Ia. You see here, flux is proportional to the current. The same I current I is flowing through this series coil, So torque is proportional to the Ia square. Flux is proportional to Ia. Similarly here, flux is, each motor has a field flux carrying a current of I by 2. It has a carrying a current of I by 2. So torque is proportional to Ia. Okay, Ia by 2. So here what is the current it is taking for each motor? Ia by 2 only, not Ia here. Okay, so Ia by 2. So torque is proportional to Ia square by 4. So here carrying torque is proportional to phi into Ia. Okay, torque is proportional to phi into Ia. So each field flux is carrying a current Ia. Okay, so flux is proportional to Ia. That's why it is flux is proportional to Ia. So Ia into Ia, that is Ia square. But here in parallel, torque is proportional to phi into Ia. Okay, we know this formula. But here current, each armature current is Ia by 2. Here you can see here Ia by 2. So torque is proportional to Ia by 2. Flux is also is proportional to Ia by 2. Torque is proportional to Ia square by 4. So T series by T parallel equal to Ia square by 4, that equal to 4. So T parallel equal to T series by 4. So this will be the answer. Option will be the torque, if the motors are connected, the torque produced by the parallel will be T by series torque is T given, T by 4. T by 4 is the answer. Let's see the next. So next question is, a synchronous phase modifier as compared to the synchronous motor is used for mechanical load. Okay, so synchronous phase modifier, it is used for voltage control. Synchronous phase modifier, you already know that synchronous phase modifier is used for voltage control, okay, on load. A overexcited synchronous motor on no load, it acts as a synchronous condenser. Overexcited synchronous motor under no load acts as a synchronous condenser. Okay, whereas underexcited synchronous motor under no load acts as a synchronous coil. Okay, it acts as a coil, inductive coil. So this is a synchronous phase modifier on load. A overexcited synchronous phase modifier is also overexcited, but it's under load. Okay, so what is the difference between the synchronous phase modifier and synchronous motor is, synchronous phase modifier and synchronous motor difference is, it has a smaller shaft. Synchronous phase modifier has a smaller shaft but rotates at higher speed compared to that of a synchronous motor. Synchronous phase modifier have a smaller shaft but rotated higher. So that is the difference between the synchronous phase modifier and the synchronous motor. Okay, so kept in mind that what is the difference between synchronous phase modifier and synchronous motor is, it has a synchronous phase modifier has a smaller shaft and rotates at larger speed. Next question. So see this here, interpoles are meant for. So what are the interpoles? Interpoles are nothing but the poles placed in between the main poles to nullify the effect of the armature reaction. Okay, so here what is the option given? Increase the speed of the motor. Okay, it is not the answer. Increasing the counter EMF, it is not the answer. Strengthening of the main field, not the answer. Reducing the sparking at the commutator, it is the answer. So if you, what is the effect of the armature reaction? It gives the sparking at the commutator. Reduce the sparking at the commutator. It produces sparking at the commutator. To reduce the sparking at the commutator, we are using interpoles. Okay, to reduce the effect of the armature, interpoles is nothing but to reduce the effect of the armature reaction under which axis? So if you see here, this is a north pole and this is a south pole. You have interpole here. So along air gap, this is what is interpolar axis? This is a polar axis. So interpoles are placed in interpolar axis or quadrature axis. Okay, compensating windings are placed in polar axis under poles. Here you place compensating winding. So you know that the interpole windings and compensating windings are connected in series with armature. Okay, you look at this topic one time. Okay, it's enough. So interpoles are meant for reducing sparking at the commutator, and you remember that interpole winding and compensating winding are connected in series with armature, and interpoles are placed along the quadrature axis or interpolar axis. This is a quadrature axis, this is a polar axis or direct axis. Okay, so compensating winding are placed along the polar axis, and I have a question on this. Okay, in case of generator, interpoles are ahead in the direction of the generator, or ahead in the direction of the generator, or ahead in the opposite direction of the generator, in the direction of the rotation. So you kindly observe, see the topic of that and comment the answer in the comment box, whether it is ahead in the direction of the rotation or ahead below in the direction of the rotation. Okay, interpoles when it is rotated. So how will be the poles, whether here north, suppose if I have a north pole here, if I have a south pole here, if I place an interpole here, these are interpoles. What this, whether it is a north pole or south pole, if it is a motor, if it is a generator, what is it is. So please answer in the comment box. Next question: what is the purpose of the conservator in the transformer? What is the purpose of the conservator in the transformer? So let's see the options. What is the purpose of the compensator? Means to cool the winding, wrong. To prevent moisture in the transformer, this is wrong. To prevent the short circuit of the primary, so this is wrong. So to take up the contraction and expansion of the oil, this is a conservator is nothing but to see the contraction and expansion of the, and conservator is placed at the top of the transformer. Conservator is placed at the top of the transformer. Okay, what is the purpose of the conservator? Means to take up the contraction and expansion of the oil. Okay, it serves as a what is use of the oil in the conservator? What is use of the oil in the conservator? Please provide the answer in the comment box. Okay, next question. If the copper loss of the transformer at 7/8 of the full load is 4900 watts, then its full load copper loss is, okay, then its full load copper loss is. So we know that at maximum efficiency, x square into full load copper loss, x square into full load copper loss equal to iron loss. We know that. Okay, you are well known about that. X square into full load copper loss equal to iron loss. So x equal to root of iron loss by full load copper loss. Full load copper loss. So here at copper loss at 7/8 of the full load. 7/8 of the full load. 7/8 of the full load is copper loss is given. He asked at full load copper loss, right? See here at maximum efficiency, okay, x square into full load copper loss equal to iron loss, at x equal to iron loss by full load copper loss. But I taken this is wrong because he does not give any information about iron loss, right? He does not give information about iron loss. So x square into full load copper loss, x square into full load copper loss at any fraction of the copper loss, you know that copper loss, we know that copper loss at any fraction, x of full load equal to x square into full load copper loss, x square into full load copper loss. Copper loss at 7/8 of the full load is 4,900. So copper loss at any fraction. So copper loss at 7/8 of the full load is 4,900. Copper loss at 7/8 of the full load. Copper loss at any fraction of x of full load is x square into full load copper loss. Copper loss at 7/8 of the full load is 4,900. X square 7 square divided by 8 square into full load copper loss. Okay. He asked what is full load copper loss. What is full load copper loss here? Full load copper loss equal to 4,900 into 8 square by 7 square. So 4,900 into 64 into 49, 4,900, you have 6,400 watts is the answer. Okay, let's see next question. So let's see another question. A 20 kVA 2000 by 200 volts 2-winding transformer when used as an auto transformer with constant voltage source of 2000 volt is capable of handling. So what we do mistake in this question is, let's see this question. I have, this is 2000 and this is 200 volts. This is 200 volts. If I convert to the auto transformer, he does not mention about additive polarity or subtractive polarity, but we know that the A value should be transformation ratio, turns ratio of the auto transformer must be greater than 1. Or A equal to high voltage by low voltage. High voltage by low voltage, in we consider in the auto transformer. If I consider 2000 volt as a constant voltage source in auto transformer, what is the possibility I have? 2000 plus 200, one possibility, additive polarity. Another possibility is 2000 by 2000 minus 200. So this is equivalent to 2000 divided by 2200. So this is equivalent to 2000 by 1800. So what is the transformer turns ratio? Auto transformer turns ratio, that is high voltage by low voltage side, 2 11s, 2 10s. Okay, what is the transformer turns by subtractive polarity? You have A equal to 2000 divided by 1800. High voltage side by low voltage side. So you get 10 by 9. So this is always greater than 1. This is always greater than 1. Okay, this is always greater than 1. So two possibilities will be there here. Two possibilities will be there. Let's see here what are the possibilities. These two possibilities there. So if I consider what is the kVA, 20 kVA. Okay, so 20,000 divided by 2000, you have 210 amperes here. 20,000 divided by 200, here you have 100 amperes here. Okay, you have 100 amperes here. So if I consider 2000 by 2200, so if I consider 2000, you have additive polarity 200. What is the current flowing through 200? 100 amperes. 100 amperes. So 100 into 2000, 200, 100 into 2000, 100 into 2000 to 200, you have 22 kVA. So you have 220 kVA. If I consider 1800 into 100, sorry, 2000 minus 200, 1800. So you have 2000 and subtractive polarity of 200. Subtractive polarity of 200. The current flowing through this cell, through this winding, you have 100 ampere. 100 ampere. So you have 1800 kVA. 1800. So 1800 into 100, that is 180 kVA. So here 180 kVA is not there. 220 kVA is the answer. Let's see the next question. Which of the following motors can work satisfactorily on both AC and DC? So which motor can be used as a both AC and DC means series motor. Okay, so if DC series motor, if series motor can be used as a DC series motor, and I remove the DC supply, if I give an AC supply, it acts as a AC series motor. So that's why it is called universal series motor. AC series motor is called a AC series motor is called a universal motor. Which motor is called a universal motor? Series. So if a DC supply I removed, if DC supply of the series motor I removed, if I connect its AC supply, it works as a universal motor. Okay, you remember this. Okay, universal motor. So DC series motor can be supplied with AC also. So it acts as a universal. Eddy current loss in the ferromagnetic core is proportional to the next question is eddy current loss. We know that eddy current loss equal to K into B max square F square T square. So eddy current loss is proportional to the frequency square. Eddy current loss is proportional to the frequency square. Okay, suppose if frequency is high, remaining all terms are taken constant, thickness of the lamination will be less. If frequency is high, the thickness, the T represents the thickness of the lamination will be reduced. Okay, thickness will be reduced. Okay, what is hysteresis losses? Hysteresis loss equal to eta B max power x into F into V. X is the Tneb's coefficient, F is the frequency, V is the volume of the core. Okay, hysteresis loss also. You have to remember this. Eddy current loss is proportional to the square of the frequency, whereas in hysteresis loss is proportional to the frequency. Hysteresis loss is proportional to the frequency if he given. Okay, so this is for hysteresis losses. He does not mention whether the Bmax is constant, Bmax is not constant. Okay, if he without giving any information means you take a Bmax as a constant. If he does not give any information about the Bmax, okay, so he is not given that term the term Bmax, you take Bmax is constant. If in case he given the Bmax is not constant, V by F is variable such that V1 is constant, frequency is reduced. Okay, what happens to eddy current loss? Eddy current loss is proportional to Bmax is proportional to V by F. We know that. How can you say that? We know that EMF induced in a transformer equal to 4.44 F Bmax into AN net cross section area into turns. Okay, so what happens is supplying this induced voltage is proportional to supply voltage, frequency constant. So frequency is not constant, so frequency variable. So frequency letter 4.44 is a constant. Once you design the transformer, 4.44 is a constant. AN is the area of the cross section is constant, turns is constant. This Bmax depends upon once you design the transformer, this 4.44 is a constant. Area of the transformer is a constant. Okay, turns of the transformer is a constant. So Bmax is proportional to the E by F. Okay, that is V by F. In transformer, this remains constant. Bmax remains constant. One induction machine, in DC machine, all depends upon the Bmax equal to V by F. Suppose in transformer, Bmax is constant. If supply voltage is to make Bmax constant, supply voltage is and frequency varied simultaneously such that Bmax is constant. To remain flux in the transformer core remains constant. To remain flux in the transformer core remain constant, you have to vary the frequency and voltage simultaneously such that if voltage is if you vary the voltage and frequency simultaneously such that Bmax is constant. What happens if I make the voltage constant, if I frequency reduced, if I reduce the frequency, voltage is constant, Bmax increases. Bmax increases, what happens to magnetizing component of current increases? So if a magnetizing component of current increases, what happens to phi naught increases? Phi naught increases means no load power factor decreases. So you know very well about the transformer, so I need not explain all the things. You know this is supply voltage. This is a flux, induced EMF flux by induced EMF flux by 90 degrees in transformer. This is supply voltage. So this is magnetizing component of current. This is IW component of core loss component of the current. So this is I naught. Okay. So what happens if I make the supply voltage constant? If I reduce the frequency, what happens to Bmax increases? Bmax increases means what is responsible for the Bmax? Magnetizing component of current increases. If magnetizing component of current increases, so this increases. So this vector goes like this. What happens to phi naught? What happens to phi naught? Increases. What happens to phi naught? Increases. No load power factor decreases. Actually, the no load power factor is 0.0 and still decreases. So what happens if I make the voltage variable frequency constant? If I make frequency constant, if I make voltage variable, so voltage is 230 volts. Suppose if you have a voltage is 230 volts, you can't change that. You can reduce that, but you cannot go beyond that. Okay, so you can't go beyond that. You can reduce that. What happens? So for example, first suppose if I increase the voltage, what happens to Bmax? Bmax is increases. What happens to voltage increases? Frequency remains constant. Voltage is varying. Voltage is increasing. Frequency remains constant. Voltage is increasing. Frequency remains constant. So Bmax what happens? Increases. The voltage increases, Bmax increases. So Bmax increases, magnetizing component of current increases. Magnetizing component of current increases. What happens to phi naught increases? Phi naught increases, cos phi naught decreases. Okay, so this is the consequences. If you see in the transformer, you look at that. Okay, so let's see. Similarly, eddy current loss. Suppose if you consider eddy current losses, if I make Bmax constant, eddy current loss is proportional to frequency square. If I make Bmax constant, eddy current loss is proportional to frequency square. Suppose if Bmax is V1 by F, Bmax is proportional to V by F whole square into F square. So eddy current loss is proportional to V square. F square into F square, F square cancel. Eddy current loss is proportional to V square. So whatever the supply voltage, if you make supply voltage constant, for example, if you make supply voltage constant, if I reduce the frequency, there is no change in the eddy current losses, because eddy current loss independent of the frequency. If I substitute Bmax in terms of Bmax, if I have a Bmax, maximum flux density, if I make the voltage constant, voltage is constant. If I reduce the frequency, okay, there is no change in eddy current losses. But if I change the voltage, there is a change in eddy current losses. If I change the voltage, there is a change in eddy current losses. If I change the frequency, if I change the frequency by making supply voltage constant, there is no change in eddy current losses. There is no change in the eddy current losses. Okay, so you look at this concept of in the transformer. Next question. So what is the purpose of the dummy coil in DC machine? Okay, so next question is, what is the purpose of the dummy coil in the DC machine? So first of all, you see the options. Eliminate harmonics. A dummy coil does not lead to harmonics. In DC machine, you don't bother about the harmonics. Okay. Eliminate armature reaction. So eliminate armature reaction means it deals with interpoles and compensating winding. No use of the dummy coil here. Bring mechanical balance and bring mechanical balance of the armature. Bring mechanical balance of the body of the motor. So this is the two options you have. So what will be the possibility here? First of all, when we use dummy coil, dummy coil is in lap winding or wave winding. Okay, so I am giving the task for you where the dummy coil is used, whether it is in lap winding or wave winding. What is the purpose of the dummy coil? What is the purpose of the dummy coil? Okay, so please provide your answer in the comment box. I am giving the answer to provide mechanical balance of the armature. So the purpose of I am giving the task for you, so you can recapitulate the lap winding and wave winding, and what are the formulas related to that. What are the formulas that relate? What is the commutator pitch? What is the front pitch? What is the back pitch? Okay, so such that different type of formulas you can recapitulate one time. So I am giving that what is a dummy coil, where we use a dummy coil. Okay, right, where in which winding you have a circulating currents, in which coil you have a circulating currents. How what is the formula to eliminate circulating currents? What is eliminated for dummy coils? Okay, so you see one time the topic of the lap winding and wave winding. I am giving the answer, but you recap and recheck the answer. Next question. So this is another general question. The transformer oil should have low dielectric strength, high viscosity, low volatility, all of these. Okay, so answer will be low volatility. Whether it have high dielectric strength or low dielectric strength, you check it. Okay, so for you have a task for this, whether it's a high viscosity or low viscosity, you have check it. So it has a low volatility. Okay, low volatility, you check it. Next question. Skewing of the rotor bar eliminates. Next question is skewing of the rotor bar eliminates. Skewing of the rotor bar eliminates vibration due to unequal forces developed on the rotor. Magnetic noise and effect of the space harmonics reduce effect of the crawling and cogging. All of the above. Okay, skewing of the rotor. What is the purpose of the skewing of the rotor? நீங்க பாத்தீங்கன்னா slot harmonics leads to the cogging and crawling. Cogging வந்து magnetic logging. cogging வந்து you have a magnetic logging. Crawling வந்து 1/7 of the synchronous speed. Crawling occurs at 1/7 of the synchronous speed. So not only 1/7 of the synchronous speed, it also 1/5 of the synchronous speed. So this is 1/7 of the synchronous speed at torque slip characteristics in motoring region. Okay, so if at all crawling occurs at braking region, that will be at 1/5 of the synchronous speed. Okay, so நீங்க பாத்தீங்கன்னா torque slip characteristics பாத்தீங்கன்னா, okay, so you have a speed equal to 0, here speed equal to synchronous speed, slip equal to here 1, and here slip equal to 0, something this goes into braking region, goes into braking region. Okay, so 1/7 of the synchronous speed, you have occurs crawling at this, you have a crawling at this 1/7 of the synchronous speed, and at 1/5 of the synchronous speed, so this is a forward and this is a backward. Okay, so crawling occurs at 1/5 of the synchronous speed. If the crawling occurs in a braking region, at what synchronous speed means 1/5 of the synchronous speed. But you consider operating region. If it is so, what is the crawling means? Actually, this is a stable region. Actually, உங்களுக்கு என்ன தெரியும்? So this is a maximum torque. This is a stable region. Of the induction motor. But here, it will be operate. Here is also you are getting a stable region. At 1/7 of the synchronous speed also you are getting the stable region. Okay, that's why it is called a crawling. So it is stable at this point also. Okay, when in brake, this goes into braking region. At 1/5 of the synchronous speed also you are getting a crawling. Okay, cogging means magnetic logging due to the slot harmonics. Okay, so skewing of the rotor is used to eliminate the noise, vibration. You have a harmonic torque. So skewing, suppose if I have what is the skewing means? Suppose this is a suppose this is a rotor slot. You have a rotor slots here. You have bars, conductors like this. So you do not place parallelly. You have some inclination. Okay, some inclination to make magnetic flux distribution is sinusoidal, one thing, and the mechanical balance. So to reduce the magnetic noise, to reduce the effect of the space harmonics. So these will reduce due to the skewing of the rotor slots. Okay, that also reduce the cogging and crawling also. Next question. So EMF induced per phase and alternator depends upon the frequency, pitch factor, and distributor, and all of this. Okay, so you know very well about this. I did not explain this. EMF equal to 4.44 phi T Kp Kd, pitch factor, distribution factor, and frequency. Okay, so you are well known about that. I do not want to explain that. Next question. So next question is the voltage actually used for setting up of the useful flux in the air gap of the three-phase induction motor. So I already explained the concept of the three-phase induction motor, how to take speed of the rotor and rotating magnetic field with respect to the rotor, speed of the rotor with respect to the stator, all the things I have explained. So I do not want to re-explain this concept. So to produce the flux in the transformer core, you have to supply it is equal to the supply voltage. Okay, so the voltage actually used for setting up the useful flux in the air gap of three-phase induction motor is equal to the applied voltage. Okay, so when you get the answer equal less than applied voltage, when you get the answer that is less than applied voltage. So if you see the induction motor operation, when you doing the supply voltage, the rotating magnetic field is produced. Rotating magnetic field means useful flux only. The useful flux is produced by the supply voltage only. So when you get the when you apply less than applied voltage, if you go for transformer or if you go for induction motor, you apply if you apply short circuit test, you did not apply the rated voltage. You did not apply the rated voltage. You apply 2 to 5% of the rated voltage to produce rated short circuit current. 2 to 5% of the rated voltage. If you consider short circuit, at that point you apply less than voltage. Okay, so in short circuit test you did not apply full voltage. You apply only less than rated voltage, 2 to 5% of the voltage, rated voltage. Okay, so kindly maintain the concept of the subject, maintain the concept of the mission, so then only you can understand the, you can place correct answer, you can tick the correct answer. Okay, you can write the correct answer. Next question. So let's see the next question. If full load slip speed of the 6 pole 50 Hz induction motor is a 950 rpm, at what is the half full load speed is nearly equal to? So if full load speed of the 6 pole 50 Hz induction motor is a 950 rpm, what is the half full load speed nearly equal to? So this can be expected question for your next exam. You see here, 120 into 50 divided by, what is synchronous speed first? 620, this is 1000 rpm synchronous. Okay, slip equal to ns minus nr by ns, that equal to 1000 minus 950 by 1000, that equal to how much? 50 by 1000. I will get 5 by 100 is the slip. Slip at half load. Half load means 5 by 100 divided by 2. So 5 by 200. So what is the speed? nr equal to ns into 1 minus s. So ns is how much? 1000 into 1 minus 5 by 200. So 1000 into 195 by 200. So I will get something 2 5s, 5 5s 25, 5 9s 45 to 47, 5 1s 975 rpm is the answer. So slip rate of full load is reduced by half, reduce it to half. So this is the expected question for TNEB and TRB. So you might be okay. So let's see some important questions in next video from another subject. Okay, so kindly friends, after watching this video, please share this video link in your Facebook. Kindly share this video link in your Facebook. Kindly help other students also. Thank you. Thank you very much. Hi friends, welcome to KMED KT's education. Let's see the circle diagram concept from induction motor. Okay, so just I have brushed up your single three-phase induction motor operating principle, and you have R1, X1, R0, X0, and if I refer secondary side, R2 dash to primary side. So this is the equivalent circuit of the induction motor. Okay, இது உங்களுக்கு தெரியும் நினைக்கிறேன். Okay, so this is exact equivalent circuit of the induction motor. So I can modify this like this. So this is the modified equivalent circuit. Okay, so நீங்க பாத்தீங்கன்னா here power input, here stator copper loss, here stator core loss, here rotor copper loss, here gross mechanical power developed. So நீங்க power flow diagram பாத்தீங்கன்னா power input power ல என்ன loss ஆகுது? stator core loss, copper loss, and you have air gap power or rotor input power, and you have rotor copper loss. Then after gross mechanical power developed, then after friction loss, then after net mechanical power. So if you want air gap power, input power minus stator losses. If you want gross mechanical power, air gap power minus rotor copper loss. Something like output equal to input minus losses. Output equal to input minus losses. If I consider this as an input, this as an output, air gap power equal to input power minus losses. Gross mechanical power developed equal to air gap power minus rotor copper losses. Net mechanical power equal to gross mechanical minus friction and windage losses. So these are the power flow stages in induction motor. And you know, உங்களுக்கு என்ன தெரியும், rotor copper loss equal to S into rotor input power, gross mechanical power developed equal to 1 minus S into rotor input power. Okay, so efficiency equal to gross mechanical power developed by air gap power or input power. So this already you know. Suppose if I have S equal to 1 at slip equal to 1, air gap power equal to rotor copper loss. இப்படி P rotor copper loss equal to S into rotor input power. So S equal to 1, rotor copper loss equal to input power. And if gross mechanical power developed equal to 1 minus S into rotor input power. S equal to 1, you have air gap power. Sorry, gross mechanical power developed equal to 0. That equal to air gap power only. Okay, that equal to air gap power only. So இதெல்லாம் தெரிஞ்சுக்கங்க. At S equal to 1, gross power air gap power equal to copper losses. Air gap power equal to gross mechanical power equal to 0. Gross mechanical power equal to 0. Okay, so let's see the for example, if I consider RL circuit, I have supply voltage VI, the current is I. Let I vary R from 0 to infinity. So I know that I equal to V by R plus J omega L. I can write this as root of R square plus omega L square at an angle minus tan inverse omega L by R. I think I have written like this, R square plus omega L whole square at an angle minus tan inverse omega L by R, because in denominator plus tan inverse omega L by R. If I go numerator, I have minus tan inverse omega L by R. Okay, let see here, let R equal to 0. Let R equal to 0, what happens? I equal to V by XL at an angle minus 90 degrees. R equal to 0, you get infinity. Okay, R equal to 0, you get infinity. I equal to V by XL at an angle minus 90. Suppose if I have R tends to infinity, what happens? I equal to 0 at an angle 0 degrees, right? Suppose if I take voltage as a reference, okay, and when R equal to 0, I at an XL, I equal to V by XL, I equal to V by XL at an angle minus 90 degrees. When R equal to infinity, current equal to 0, it's an angle 0 in phase. I equal to 0 at an angle, this is a 0 degrees, it is 90 degrees. Okay, so you have R equal to 0, this is R equal to infinity. So this is a graph locus of this. So if you see here, current phasors are represented like this. When r equal to 0, I equal to VA by XL at an angle minus 90 degrees. The point is getting here. Then r equal to infinity 0 at an angle 0. I am getting this point here. So what is the diameter of this semicircle? Semicircle V by XL. What is the radius? V by 2XL. So this is the locus of the RL, and we have to observe that for RL circuit current lags the voltage. For RL circuit current lags the voltage. At some angle you have here, at some angle here. Okay, so for pure inductive load lags by 90 degrees. So this is the locus of the network for R varying from 0 to infinity. If I vary XL from 0 to infinity, now on the 0 to infinity vary pandra. So what I get? Suppose if I place XL equal to 0, what happens? I equal to V by R at an angle 0 degrees. If XL equal to infinity, I place I equal to 0 at an angle minus 90 degrees. So let's draw the plot. So I have voltage axis and this is current. So this is voltage axis. XL equal to 0, I equal to in phase, I equal to V by R at an angle 0. So current is in phase with voltage. So V by R at an angle 0. So I have V by R in phase. So this is V by R. I am showing this V by R at an angle 0. When XL equal to infinity, this is XL equal to 0. When XL equal to infinity, I have I equal to 0 at an angle minus 90. So I have this point. When XL equal to 0, I have I equal to V by R at an angle. Sorry, I have drawn wrong. So I equal to V by R at an angle 0 degree. So I have some magnitude is there. But in phase. Sorry. Let's see here. I have taken voltage axis. And let voltage axis. XL equal to 0, I have I equal to some magnitude at an angle 0. So I is in phase with voltage at an angle 0 degrees, V by R magnitude, and this is XL equal to 0. When XL equal to infinity, I equal to 0 at an angle minus 90. So I have this plot. Okay, so 0 at an angle minus 90. So this is the plot I am getting. So what is the diameter? V by R. Okay, so you can see the phasors, you can like this. So first of all, first phasor when XL equal to 0, I have the current phasor like this, and when XL equal to infinity, I have current phasor like this. So these are the phasors I get. So this is the phasor I get. So this is wrong, friends. So this is I equal to V by R at an angle 0. So I equal to not V by R at an angle some magnitude, V by R at an angle 0 degrees in phase. In I equal to in phase with voltage. If 90 degrees means I is in 90 degrees out of phase with voltage. Okay, 90 degrees lagging the voltage. So this is the locus of this network. நீங்க பாத்தீங்கன்னா இப்ப சர்க்கிள் டயக்ராம் பாத்தீங்கன்னா ரோட்டருக்கு வந்து R2 dash by S and you have X2. Okay, so this is voltage. Sorry friends, I have done mistake. So this is R2 dash means this is R2 dash into 1 minus S by S. So this is R2 dash into 1 minus S by S. So if it is not, if I not represent like this, so this will come into R2 by S only, R2 dash by S only. So this R2 dash by S I can write as R2 dash plus R2 dash into 1 minus S by S. Okay, so let's see this. So this one mark for friends. What is the diameter of the locus? So he asked to draw the locus of the network. and he asked to find what is the diameter of the locus of the network, what is the diameter, what is the radius of the locus of the network. So இது வர வாய்ப்பு இருக்கு friends. So 1 mark network theory and so next பாத்தீங்கன்னா, so this is R2 dash by S X2 dash when referred to this stator side, and you have E2 here. E2 here. Actually நீங்க பாத்தீங்கன்னா, okay, let's see R2 dash by S. So I have R2 dash by S. When S equal to 0, what happens to R2 dash by S? R2 dash by S equal to infinity. When S equal to infinity, what happens to R2 dash by S is equal to 0. Okay, so I have I equal to E2 by root of R2 dash by S whole square plus X2 dash square. Okay, at an angle minus tan inverse of X2 dash by R2 dash by S. So I can write this as minus tan inverse of Sx2 dash by R2 dash. Okay, so நீங்க பாத்தீங்கன்னா, let S equal to 0. S equal to 0 means R2 dash by S equal to infinity. R2 dash by S equal to infinity means I current equal to 0. So S equal to 0 tan inverse, so theta is 0 degrees. So current equal to S equal to infinity. For S equal to 0, current equal to 0. For S equal to infinity, current equal to S equal to 0 infinity. Okay, S equal to infinity, you get R2 dash by S is 0. So E2 dash E2 by X2 dash, that equal to theta equal to minus 90 degrees. So if you draw the phasor, this is voltage V1, E2, right? So current is 0 at an angle 0. So 0 degrees means this is, if I take reference, this is voltage is taken, I have reference. Okay, so voltage I have taken reference. So voltage I have taken reference. Okay, this is 0 degrees axis. I2 at an angle 0, I at 0 at I equal to E2 by X2 at minus 90 degrees. So I have E2 by X2 at an angle minus 90 degrees. Okay, so this is this locus. So நீங்க பாத்தீங்கன்னா, what is the radius of this? This is the first point you have to remember. E2 by X2. What is the radius of your circle diagram? E2 by X2. What is the radius of your circle diagram? E2 by X2. This question can be expected for 1 mark. E2 by X2. So mug up பண்ற தேவையில்லை, நீங்க வந்து solve பண்ணாலே புரியும். Okay, so E2 by X2. So what are the phasors here? If you see the phasors, so this is the at x equal to R2 S equal to infinity. S equal to infinity. This is at equal to 0. S equal to 0. So at S equal to infinity, this is the phasor. This is the path. This is the path. And this is the path. And this is the path. And this is the path. So this is the phasor representation. Path of this slip varying from 0 to infinity. Okay, 0 to infinity. For example, உங்களுக்கு என்ன தெரியும்? Power equal to V2 I2 cos theta 2. So power equal to V2 I2 cos theta. Let this is current is I2. This phasor is I have represented I2 phasor. This is I2 phasor. I2. So this is I2. Okay, I2 equal to this phasor. Suppose if this is a phasor, if I draw perpendicular, let I draw perpendicular. If I draw perpendicular here, this is a theta. This is a theta. So active component, this is theta. I is making a angle theta. So this is I2. This is making angle theta with E2. Okay, E2. So E2, this is an active component. E2 I2 cos theta 2 is the, let theta 2 is the angle making by I2. So this is theta 2. So I2 cos theta 2 in phase with E2. I2 sin theta 2 in phase. This component is I2. cos theta 2 and this component is I2 sin theta 2. This component is I2 sin theta 2. So நல்லா நான் வச்சுக்கோங்க friends. நீங்க பாருங்க. Let I am making நீங்க பாருங்க. நீங்க பாருங்க locus எனக்கு தெரிஞ்சு போச்சு. rotor pathோட s vary பண்றப்ப எனக்கு path வந்து இங்க பாருங்க. So this is E2 dash. Okay, so this is E2 dash and I have I2. This is I2 phasor and I have E2 by x2. E2 by x2 is the diameter. So this is a current phasor. This is a current phasor I2 that equal to E2 by x2. If I consider any one phasor, current phasor I2. So this I2 making an angle theta 2 with E2. This I2 making an angle theta 2 with E2 dash. Okay, E2 or E2 dash. I taken E2, so let me take E2 and theta 2. So I2 cos theta 2, E2 I2. So E2 I2 cos theta 2 is the active power. So E2 I2 cos theta 2. So this is an active component, I2 cos theta 2 component. Okay, so this is an active component, I2 cos theta 2. Okay, so this this represents reactive component, I2 sin theta 2. So torque is we know that torque equal to P by omega s. Torque depends upon the active power. So this represents torque. This amount represents torque. Nalla na vachunga. This amount represents torque. So V2 I2 cos theta. This also represents a power. Okay. So maximum torque power. Suppose if I draw again, suppose if I draw another phasor. Let I have this. This is an active component. Torque. So maximum torque. So I have maximum torque at 45 degrees. I have maximum torque at 45 degrees. Okay. So this is the maximum torque. Okay. So this gives power component or torque component, because torque is proportional to power. Okay. So if he given power, if you multiply divided with omega s, so divided with omega divided by omega s, you get torque. Okay. So this is one understanding. So நீங்க பாத்தீங்கன்னா this is actual s equal to 1 வந்து standstill condition. S equal to 1 வந்து standstill condition. Standstill condition என்ன நான் என்ன சொன்ன பாருங்க, speed equal to 0, slip equal to ns minus n0 by ns. So speed equal to 0, slip equal to 1. So நான் வந்து அந்த slip equal to I have blocked the rotor tight up புடிச்சிக்கிட்டேன். ஓகேவா? So this is the condition, first condition. So I know the path when I know the path when I vary from slip equal to 0 to infinity. So this is the path. This is the path. This is V1. Let I have this is current phasor I1. Okay. So நீங்க பாத்தீங்கன்னா what is the diameter? Very important. What is the diameter? First diameter V by x1 is the diameter. What is the radius? V by 2x1. Okay. At slip equal to நீங்க பாத்தீங்கன்னா this is slip equal to infinity and this equal to slip equal to 0. Okay. So at slip equal to 1 in the graph line, the locus line எங்கேயாச்சும் இருக்கலாம். ஓகேவா? So நீங்க பாத்தீங்கன்னா let எனக்கு வந்து slip corresponding to maximum torque இது வருது. So நீங்க இப்ப நான் சொன்ன maximum torque வந்து பாத்தீங்கன்னா if I drawing like this, I have maximum torque at this point at an angle 45 degrees. Okay. So நீங்க பாத்தீங்கன்னா slip corresponding to maximum torque வந்து R2 by x2. Okay. So x by r ratio of this inductor, x by r ratio of this circuit must be greater than 1. So x by r ratio of this நீங்க பாத்தீங்கன்னா x value r value ஓட ஜாஸ்தியா இருக்கும். So x by r greater than 1. leakage reactance ஓட resistance value ஜாஸ்தியா இருக்கும். So நீங்க பாத்தீங்கன்னா அப்ப slip corresponding to maximum torque வந்து less than 1. So அப்ப இந்த point 1 less than 1 தானே, இந்த point வந்து less than 1 தானே. நீங்க பாத்தீங்கன்னா ஒரு சர்க்யூட்ல x value greater than r, so x by r value something greater than 1. ஓகேவா? So slip corresponding to maximum torque வந்து r2 by x2. it should be x by r greater than 1 r by x less than 1. So இது less than 1 na, so இங்க எங்கேயோ greater than less than greater than 1 இருக்கு மாதிரி தானே. so இங்க எங்கேயோ 1 இருக்கு, 1 ஓட கம்மியா இருக்கு, இங்க 1 ஓட கம்மியா இருக்குன்னா அப்ப இங்க slip equal to 0, இங்க less than 1, so இங்க 1 இருக்கு. so for example at that point I take s equal to 1. okay, at that point I take slip equal to 1. correct? so நான் என்ன பண்றேன், this is the point O. yes, at this point slip is 1, at this point slip is 1, slip is 1, this is smallest, slip is 1, capital S. okay, so if I draw perpendicular this, okay, I draw perpendicular, this is a current phasor. இப்போ நீங்க உள்ள draw பண்ணதெல்லாம் current phasor. so இது at slip equal to 1 I draw the current. நான் current draw பண்ணேன், ஆனா வந்து rotor rotate பண்ணல. ஓகேவா, ரோட்டார் வந்து ட்ரை பண்ணது ரொட்டேட் பண்றதுக்கு, ஆனா ரொட்டேட் ஆக மாட்டேன், ஏன்னா கரண்ட் இருக்கு இல்லையா, கரண்ட் புரிஞ்சா. so at starting slip equal to 1 I have a current, the current carrying conductor placed in a magnetic field, the force will develop, but at that time I am blocking the rotor. நான் வந்து slip equal to 1 block the rotor, டார்க் டெவலப் ஆகுது, ஆனா நான் பிடிச்சிருக்கேன் கெட்டியா, ரொட்டேட் ஆகவே இல்லை. ஓகேவா, so let this make angle theta 2. let this make an angle theta 2. so இங்க theta 2 னா இங்க பாருங்க, உங்களுக்கு இங்க theta 2 னா இங்க theta 2. கரெக்ட்டா? so power input power equal to, so நீங்க பாத்தீங்கன்னா input power equal to 3v1 i1 cos theta 1. input power equal to 3v1 i1 cos theta 1. so இது I1 current phasor. so let I take this theta 1. okay, this is theta 1, this is current phasor, this is a current phasor. so I1 cos theta 1 is the component, I1 cos theta 1 is the active component of this voltage. so நீங்க பாத்தீங்கன்னா this is I1 cos theta 1. so this is I1 cos theta 1. okay, so this is I1 sin theta 1. this is I1 sin theta 1. so power equal to 3v1 I1 cos theta 1. let I take this as m, point m. so in the component on the power component, so you get clear. okay va, so நீங்க பாத்தீங்கன்னா power equal to 3v1 I1 cos theta 1. so இந்த component பாருங்க, இந்த component வந்து vertical component, so vertical component வந்து இது sm. so நீங்க பாத்தீங்கன்னா power equal to 3v1 I1 cos theta 1 value equal to sm, I1 cos theta 1 value equal to sm, 3v1 sm. கரெக்ட்டா? நீங்க இப்போ இது angle theta 1 னா இது angle theta எடுக்கணும். அப்போ இந்த காம்போனன்ட் தானே OS equal to, so OS cos sm equal to OS cos theta 1 அப்படி கூட எடுத்துக்கலாம். OS cos theta 1, நீங்க பாருங்க இது theta 1 னா இது horizontal component, இது vertical component. OS cos theta 1 is also active component. okay, so உங்களுக்கு என்ன தெரியும், power equal to 3v1 s1 is the active component at slip equal to 1, at slip equal to 1, input power equal to, at slip equal to 1 input power equal to, நான் ஆல்ரெடி சொன்னேன், இங்க பாருங்க rotor copper loss equal to s into rotor input power, gross mechanical power developed equal to 1 minus s into rotor input power. slip equal to 1, what happens, rotor copper loss equal to rotor input power. so இங்க பாத்தீங்கன்னா gross mechanical power developed equal to 0. so at slip equal to 1 rotor input power which I have calculated, that equal to rotor copper loss, ஓகேவா. so இப்போ நீங்க பாத்தீங்கன்னா நாளைக்கு எக்ஸாம்ல இந்த locus கொடுத்துட்டு ஓகேவா, இந்த locus கொடுத்துட்டு slip at slip equal to 1 at slip equal to 1 ஒரு லைன் கொடுத்திருக்காங்க at slip equal to 1 ஒரு லைன் கொடுத்திருக்காங்க at slip equal to 1 ஒரு லைன் கொடுக்கறப்ப இந்த vertical component என்ன ஆகுது air gap input power that equal to air gap input power that equal to rotor copper loss that equal to air gap input power நல்லா அப்சர்வ் பண்ணலாம் ஒரு தடவை அப்சர்வ் பண்ணிட்டா நெக்ஸ்ட் ஈஸி air gap input power equal to rotor copper loss okay so torque இது torque so இந்த amount வந்து torque இதுக்கு torque equal to power by omega s so omega s divide பண்ணா உங்களுக்கு torque வந்துரும் clear so I taken at any other slip இப்போ நான் என்ன பண்றேன் at any other slip s எடுத்துக்கிறேன் at any other slip so இப்போ பாருங்க at slip equal to something value is so at some slip I don't know at what slip is at I taken this slip is if I draw perpendicular here let this angle is theta 2 so in the angle theta 2 na in the angle evlo aagudhu theta 2 okay is slip equal to one line friends slip equal to one line at other some slip 0.4 s or 0.5 s ena eduthukiren so this angle makes theta 2 let I have it so idu vandu n let I have this n this is point O so let I have this point C okay so உங்களுக்கு geometry என்ன தெரியும் பாருங்க இப்ப I have this if I draw perpendicular and I have this so OA equal to OM into C so OA equal to so if it is a semicircle if I have இங்க பாத்தீங்கன்னா let I have a semicircle and I have such that okay so M OM இருக்கு ஓகேவா இது perpendicular நான் டிரா பண்ணேன் இது perpendicular பண்ணேன் இப்போ நான் என்ன பண்றேன் இது டிரா பண்றேன் C ஓகேவா so OA square equal to OM into OC OA square equal to OM into OC இது actually from geometry OA square equal to OM into OC இப்போ பாருங்க so இப்போ பாருங்க friends so ஒரு பாயிண்ட் இது ஒரு பாயிண்ட் P நினைச்சுக்கோங்க ஓகேவா at point slip at any point slip S so நீங்க பாத்தீங்கன்னா this point is C இப்போ நீங்க வந்து பாருங்க இது ஒரு அரே இருக்கு இப்போ நான் இப்படி சால்வ் பண்ணா OA equal to OA square equal to OP square equal to ON into OC for this triangle OPN similarly for triangle OSM I get OP square equal to OS square equal to OM into OC so inga draw perpendicular panna M irukku okay va so OP square equal to ON square OC square OS square equal to OM into OC okay va right so நீங்க பாத்தீங்கன்னா OP square by OS square equal to ON into OC OM into OC so ON by OM OC cancel out OP square by OS square equal to ON by OM so இப்போ பாத்தீங்கன்னா இது ஒரு current phasor at slip equal to 1 this is a current phasor at any some other slip it is the current phasor okay so rotor copper loss at any slip S that is at point P at any slip S point P rotor copper loss at S equal to 1 okay so rotor copper loss at any point is that equal to this current into this current what is the current OP square into R2 dash At S equal to 1, OS square, that is the current, OS is the current. So rotor copper loss at any point S, this point, this is OP is the current. So OP square into R2 dash and OS square into, at this slip equal to OS square into R2 dash, that equal to R2 dash cancel. So OP square by OS square. So what is OP square by OS square? ON by OM. ON by OM from this. ON by OM. So what is ON? This is ON and this is OM. These are two similar triangles. What is the two similar triangles? O, let this point is G. Let I take this point is G. So ONG one triangle and OMS, this is another triangle, similar triangles. So ONG one triangle, OMS is another triangle. So ON by OM equal to, I can write this as GN by SM. GN by SM. Correct? I can write like this. Rotor copper loss at any rotor copper loss at any S equal to GN by SM into rotor copper loss at S equal to 1. At S equal to 1. Correct or not? Okay. So நீங்க பாத்தீங்கன்னா இங்க பாருங்க. So இங்க பாருங்க. OP square equal to OS square. OP square equal to OS square. Sorry. OP square by OS square into இங்க பாருங்க. OP square by இங்க பாருங்க. OP square by OS square into SM equal to GN. Correct? OP square by OS square equal to finally ON by OM that equal to GN by SM. Okay, so from this GN equal to OP square. OP square enna? OP square inga parunga. OP square equal to current square I2 square. OS square enna? Current at slip. So idu enna pandra I2 square into SM into OS square equal to GN. So SM enna? SM point enna? In the point SM enna? Rotor copper loss. Air gap power that equal to rotor copper loss. So நீங்க பாத்தீங்கன்னா I2 square into I2 square R2 dash இங்க பாருங்க I2 square என்னது OP square on the I2 square SM on the rotor copper loss I2 square into, so இது I2 only okay, I2 square I2 dash square into R2 dash I2 square dash into R2 dash OS square is current at slip S equal to 1. So if I cancel it, I will get OP square into R2 dash. OP square is nothing but current square, I square into R2 dash. So this is copper loss. So this GN is a copper loss. Okay, so this is copper loss at any slip S. Okay, so பாருங்க இது பாருங்க இது slip equal to one line at S equal to 1 I have taken any point on this locus. I draw that line. So if I divide this point, this gives the rotor copper loss. So GN gives the rotor copper loss. Okay, so GN gives the rotor copper loss. So if this rotor copper loss, PN is the, so PN enna PN தெரியாத உங்களுக்கு PN என்ன PN. So this is a theta 2. If I draw this is input power at any slip S. So 3 V2 I2 cos theta 2 at any slip S. This is the input power. So PN is the input power Pn is the input power. So let's see here. So what is Pg? Pg equal to the Pg equal to Pn minus Gn. Pn minus Gn. What is Pn? Pn is input power. Input power means air gap power. Input power means air gap power. Air gap input power. Okay, so rotor input power minus Gn. Gn is a rotor copper loss. Gn is a rotor copper loss. So what is that? Input power minus rotor copper loss. What you get? Gross mechanical power developed. So gross mechanical power developed. Correct? Input power length rotor copper loss edutha. So inga parunga. So rotor input power inga mele potukku inga parunga. Okay. Right. So rotor input power is air gap power or rotor input power. This is gross mechanical power developed. So gross mechanical power developed equal to rotor input power minus rotor copper losses. So rotor gross mechanical power developed equal to rotor input power minus rotor copper losses. So first கொஞ்சம் போர் அடிக்கும் ஃப்ரெண்ட்ஸ், சின்னமா புரிஞ்சுக்கிட்டா நாளைக்கு வந்தா ஒரு மார்க் கம்பல்சரி. So இங்க பாருங்க, இந்த Pg represents gross mechanical power, Pn represents total input power. So இங்க பாத்தீங்கன்னா இது வந்து என்ன லைன்? Input power line. This is a input power line. Basic பாத்தீங்களா, அது input power line. So உங்களுக்கு question என்ன கேட்பாங்கன்னா, what is the diameter of the input power line for the rotor circuit? அது வந்து rotor circuit analysis மட்டும் தான் கேட்டேன். ஓகேவா? rotor circuit analysis மட்டும் தான் கேட்டேன். This is a rotor copper loss. So இது வந்து rotor circuit analysis பண்ணிட்டேன். இப்போ வரைக்கும் என்ன பண்ணோம்? rotor circuit analysis பண்ணோம். ஓகேவா? So நீங்க பாத்தீங்கன்னா இங்க பாருங்க, இது வந்து கிராஸ் மெக்கானிக்கல் பவர் டெவலப். நீங்க இப்ப எங்க எடுத்துக்கிட்டாலும், சோ இந்த லைன்ல இருந்து எந்த லைன்? ஏர் கேப் லைன்ல இருந்து பாருங்க, ஸ்லிப் ஈக்குவல் டு 1. ஏர் கேப் லைன் இல்ல, ஸ்லிப் ஈக்குவல் டு 1 லைன். ஸ்லிப் ஈக்குவல் டு 1 லைன்ல இருந்து நீங்க எங்க எடுத்துக்கிட்டாலும் this represents gross mechanical power developed. So gross mechanical power developed. So this is an output line. Diameter of the output line is a V by X1. Okay, so let's see if I consider stator. நீங்க வந்து equivalent circuit பாத்தீங்கன்னா R1. So I modified equivalent circuit R1, X1, R2 dash by S and X2. This is the modified equivalent circuit of the single three-phase induction motor. So இப்போ பாத்தீங்கன்னா actually நீங்க பாத்தீங்கன்னா this is consists of I1 and this is I0 and this is of I1 dash. So இப்போ நம்ம என்ன கண்டுபிடிக்கணும்? ஸ்டேட்டர் காப்பர் லாஸ் இன்க்ளூட் பண்ணணும். என்ன பண்ணணும்? ஸ்டேட்டர் காப்பர் லாஸ் கூட இன்க்ளூட் பண்ணணும். ஓகேவா? ஸ்டேட்டர் காப்பர் லாஸ் கூட இன்க்ளூட் பண்ணணும். So let's see here. So இப்போ பாத்தீங்கன்னா I1 equal to I0 plus I2 dash. I1 dash. ஓகேவா? I1 equal to I0 plus I2 dash or I1 dash. So let's take I2 dash. நீங்க I2 dash the form அங்க எடுத்திருக்கீங்க. So I2 dash. So நீங்க பாத்தீங்கன்னா suppose this is a voltage V1. So I have this is voltage V1. Let I have this voltage V1 here, and I have load current I0. No load current I0. So this is phi naught. Okay. So if I draw this, so you see here I0 plus I2 dash. I1 equal to I0 plus I2 dash. So I2 dash நீங்க பாத்தீங்கன்னா I2 இங்க சர்க்யூட் பாத்தீங்கன்னா இதுக்கு முன்னாடி நம்ம டிரா பண்ணது. சோ இங்க பாருங்க, ஸோ இங்க பாருங்க, இங்கேருந்து நம்ம டிரா பண்ண சர்க்கியூட். ஸோ முன்னாடி வந்து எக்ஸ்ட்ரா இது இருக்கு. ஸோ இது வந்து R1 X1 R2 dash by X2, இது வந்து நம்ம டிரா பண்ண சர்க்கியூட். ஸோ இது வந்து I2 dash locus, இது வந்து I2 dash locus. So let I take I1 here, I0. So this is I2 dash. Let this is I2 dash. So நீங்க பாத்தீங்கன்னா I1 equal to, so this is I1. So இது நமக்கு தேவையில்லை இப்ப. So இப்ப பாருங்க, இது இப்ப நான் டிரா பண்ணனா ரொம்ப கன்ஃபியூஷன் ஆயிடும். So I1 எடுக்கிறேன் இப்ப. So I1 டிரா பண்ணாம நான் டிரா பண்றேன். ஓகேவா? So this is I0. So I0 வந்துச்சு, I0 with respect to phi 0. So and if I draw the locus for I2 dash, this is the locus. If I take any point on the phasor I2 dash, if I0 plus I2 dash is I1. So this is the logic behind this. Okay? So இப்ப பாருங்க, இது பாத்தீங்கன்னா I0. So இது வந்து I0 cos phi 0, I0 cos phi 0. So no load power gives I0 cos phi 0 into no load core loss. So this vertical component gives the no load core loss. I0 cos phi 0 into V1, I0 cos phi 0 active component on the I0 cos phi 0 into V1 no load core loss. So this component gives the no load, what is that? No load core loss. So நீங்க பாத்தீங்கன்னா I have a slip line S equal to 1 here. I have S equal to 1 slip line. S equal to 1 slip line. Okay, wow, S equal to 1 slip line. And let I take this and I draw perpendicular. I take slip S equal to 1 line here. Let I take here. And I take at any point S 1 point. I draw perpendicular. This is P and this is S. I draw perpendicular and I draw perpendicular. Okay, I draw perpendicular. Let this is M. Let this is N and this is M. Okay, so what SM represents? What SM represents? What SM represents? SM represents air gap power, air gap input power or rotor input power, air gap input power or rotor input power or rotor copper loss. So rotor copper loss. So at S equal to 1, air gap power equal to input power, that equal to rotor copper loss, that equal to rotor copper loss. Okay, rotor copper loss. Right. Okay. Then after, நான் என்ன எடுத்துக்கிறேன் இப்ப பாருங்க, divide such that R1 and R2 dash resistance R1 கொடுத்திருப்பாங்க, R2 dash கொடுத்திருப்பாங்க, divide SM such that R1 by R2 dash such that equal to இங்க பாருங்க, let I take this point L. Okay, so ML by SL. ML வந்து R1, SL வந்து R2. I am dividing such that R1 and R2 dash. I am dividing such that R1 and R2 dash such that in terms of ML and SL. Okay, so இங்க வரும் உங்களுக்கு கிராஃப் தியரி புரிஞ்சு போச்சு. இப்போ என்ன பண்றேன், இப்போ எக்ஸ்ட்ரா வந்து ஸ்டேட்டர் ரெசிஸ்டன்ஸ் கொடுத்துருக்காங்க. ஸோ நான் இப்போ இந்த ரோட்டார் காப்பர் லாஸ் லைனை டிவைட் பண்றேன் R1 into R2 dash. So this ML is R1 dash and this is R2 dash. கீழே வந்து ஸ்டேட்டர் ரெசிஸ்டன்ஸ், மேல வந்து ரோட்டார் ரெசிஸ்டன்ஸ். ஓகேவா? சோ நீங்க பாத்தீங்கன்னா அதுக்குண்ட ஒரு லைன் டிரா பண்ணுங்க. ஓகேவா? சோ நீங்க பாத்தீங்கன்னா OS square into R1. So this is a current OS. So let I take this is O and this is O dash. So OS square into R1 gives stator copper loss. OS square into R2 dash it gives rotor copper. This is R1 gives stator copper loss and this is to R2, this is gives rotor copper loss. Okay, ma? Rotor copper loss. இங்க பாருங்க, G, let I have a point G and I have K. and I have K. So இது வந்து rotor copper loss, இது வந்து stator copper loss. நீங்க single triangular rule apply பண்ணாலும் இங்க பாருங்க apply பண்ணா இது கூட என்னது stator copper loss, sorry இது rotor copper loss, இது stator copper loss. GK is rotor copper loss at any slip S. GK is rotor copper loss at any slip S, and Kn is stator copper loss at any slip S. At any slip S. Okay va? So நீங்க பாத்தீங்கன்னா the line which divides air gap input power. So இங்க பாருங்க mechanical input power. So இது பாருங்க இது mechanical power or air gap power, gross mechanical power. இது rotor copper loss, இது வந்து stator copper loss, இது வந்து no load rotation loss. So this is total input power. So நீங்க பாத்தீங்கன்னா இது input power line, இது வந்து input power line, இது வந்து air gap power. This is one mechanical output line. This is one output line. So slip equal to one line வந்து output line. So the output line அங்கேருந்து தான் உங்களுக்கு output வருது. நீங்க பாத்தீங்கன்னா இங்க பாருங்க மேல ஒன்னு சொல்லிட்டு பாருங்க. So this is the gross mechanical power output. From this slip equal to one line, whatever you taken from that point, you get mechanical output line. So slip equal to one line is a output line. Okay va? So நீங்க இது பாத்தீங்கன்னா this is a torque line. So இப்போ இங்க பாத்தீங்கன்னா இங்க gross mechanical power output, இங்க PG is gross mechanical output. Okay va? So gross mechanical output எந்த லைன்ல இருந்து gross mechanical slip equal to one line ல இருந்து gross mechanical output, slip equal to one line ல இருந்து gross accord. So slip equal to one line is output line. Slip equal to output line. நீங்க பாத்தீங்கன்னா gross mechanical output or GK is the rotor copper loss. So இங்க rotor copper loss. So இங்க இந்த லைன் பாத்தீங்கன்னா yellow line, இது வந்து என்ன பாத்தீங்கன்னா டார்க் லைன். எதுக்கு டார்க் லைன்? உங்களுக்கு டார்க் எங்க டெவலப் ஆகுது? ரோட்டார் கிட்ட. சோ ரோட்டார் இன்புட் பவர் எங்க இருந்து? இங்க ரோட்டார் இன்புட் பவர் எங்க இருந்து? இங்க. புரியுதா? சோ GK கிட்ட இருந்து அவுட்புட் லைன். This is a torque line. So the line which divides resistance R1 and R2 is known as torque line, because at that from that only you get rotor copper loss, then after you get air gap line. The line is slip equal to 1 is called an output line, because at that line only you get an output, gross mechanical output. So இங்க இருந்து பாத்தீங்கன்னா இந்த அவுட்புட் டார்க் லைன்ல இருந்து பாத்தீங்கன்னா rotor copper loss, air gap, இங்க air gap input power ல இருந்து rotor copper loss ல இருந்து gross mechanical output. From you get output line, you get gross mechanical output. Okay va? So rotor part line எங்க ஸ்டார்ட் ஆகுது? டார்க் லைன்ல இருந்து ஸ்டார்ட் ஆகுது. So rotor copper loss ல இருந்து ஸ்டார்ட் ஆகுது. So slip equal to one line, the graph is given if the slip equal to one line is called output line. The slip equal the torque line is nothing but dividing resistance R1 and R2 is called a torque line. So the கீழ இருக்கிறது வந்து stator copper loss, மேல இருக்கிறது வந்து rotor copper loss. So total length across V1 axis is a active component. So 1 mark compulsory. अगर கொடுத்த question compulsory TNEB ல வந்தா வரும். So TRB political வந்தா வரும் friends. So என்ன output line, எந்த rotor line, எந்த copper loss, எந்த stator copper loss, எந்த rotor copper loss. Okay வா? So அந்த locus diagram network field ல வர்ற வாய்ப்பு இருக்கு friends. Okay வா? So this is the circle diagram. Circle diagram ஓட the point which required. Okay, அதுக்கு அப்புறம் நீங்க பாத்தீங்கன்னா இந்த பாயிண்ட் கொடுத்துட்டு SM வந்து என்ன, rotor copper loss கொடுப்பாங்க. நீங்க வந்து rotor copper loss, ஒருவேளை rotor analysis, நான் first rotor analysis சொல்லி அதுக்கப்புறம் stator analysis போறோம். rotor analysis ல இருந்தா stator analysis புரியும். ஓகேவா? சோ இப்போ பாத்தீங்கன்னா rotor analysis எங்க வர போறது பாத்தீங்கன்னா, சோ நீங்க பாத்தீங்கன்னா rotor analysis பாத்தீங்கன்னா எங்க வர போறது தெரியுமா? எங்க பாருங்க, rotor analysis வந்து இங்க வருது. எங்க இருக்கு? இது வந்து rotor analysis. இந்த டயகிராம் தான் இது, கீழ எல்லாம் இல்ல, இந்த டயகிராம் தான் இது. இந்த டயகிராம் தான் இது. எங்க இருக்கு? இந்த டார்க் லைன்ல இருந்து இந்த டார்க் லைன்ல இருந்து. சோ இப்போ இது என்ன ஆகுது, டார்க் லைன். ஸ்லிப் ஈக்குவல் டு 1 லைன் ரோட்டர் காப்பர் லாஸ். எங்க ரோட்டர் காப்பர் லாஸ் கட் பண்றோம் பாத்தியா, ரோட்டர் காப்பர் லாஸ் கட் பண்றோம் பாத்தியா, அது வந்து டார்க் லைன். சோ இப்போ ரோட்டர் இங்க இருந்து ரோட்டர் காப்பர் லாஸ் இருக்காமல, அங்க ரோட்டர் அனாலிசிஸ் பாத்தீங்கன்னா இங்க இருந்து ரோட்டர் காப்பர் லாஸ் இருக்கு. சோ திஸ் இஸ் தி டார்க் லைன் ஹியர். திஸ் இஸ் தி டார்க் லைன். நான் இன்புட் லைன் சொல்லிருக்கேன். சோ திஸ் இஸ் தி டார்க் லைன் ஆர் இன்புட் லைன். This is output line. Slip equal to 1 is the output line. ஓகேவா? So first ரோட்டர் அனாலிசிஸ் புரிஞ்சாதான் ஸ்டேட் அனாலிசிஸ் வச்சு உங்களை அனாலிசிஸ் பண்ண முடியும். ஓகேவா? So thank you friends. Share to your friends. Thank you.